Thank you. Can you hear me? Great. So, ladies and gentlemen, dear distinguished guests, I have the great honor to welcome you all today to the Advanced Yachting Technology Conference in the Yacht Club de Monaco. So why we are here today, I think it's obvious. The maritime and the yachting sector need to change. These sectors need rapid change. And I believe that such an impactful change requires strong commitment, leadership, and also collaboration. These are elements of change, what we are trying to aim with the Monaco Energy Boat Challenge. After this conference, I would like to welcome you all to the quayside, where the future is happening right now. We are testing cutting-edge technologies on water, so please come and witness these moments with us. And now I would like to invite Bernard D'Alessandri to the stage to share his views with us regarding the Monaco Energy Boat Challenge. Thank you very much for coming today and being with us. Thank you.
Thank you, Sila. Thank you, Laura. And good day, everybody. Someone was at the party last night or not? No? No? You? Only one? The rest is sleeping? The rest of the people are sleeping now? No, thank you. For the 12 times we organize these events, and we are quite enjoy about the result of that, because every year we improve more. Our vision about the yachting is a part of the tourism, and that is very important. You know, when we are talking about just yachting the yachting is nothing. It's just a part of the tourism, and then you have to change this idea of the yachting and for the yachting. The yachting is a part of the tourism, is a special tourism, but like this we can have another image of the yachting, and I think it will be easier. And if you are talking about tourism, everywhere, in the mountain, everywhere, in Iceland, everywhere, we are protecting the nature against the tourism, and we are moderate the number of the people that can go in Calanque de Cassis, in a mountain, you know, everywhere is a regulation. Obligatory to be a regulation also for the yachting. But we don't have all the solution for the moment, and we have to take care about that, because you know, when the regulation will arrive, it will be very difficult to use a boat. I would like to take the example of the buoy, the mooring. I don't know if you are following that, but during 5 years, the government and Europe said, you know, it will be impossible to move for the big boat over 44, 45 meters near the coast. Nobody moved, no municipality, no department, nothing, except someone in Corsica. It was free. It was not free, but the financement was done by the state. And today we don't have a mooring, but we have still the problem of the boat. And for us, or you have the obligation and you respect the law, or you are losing a yacht, like is the case everywhere in France. Last year it was very difficult, because the people, they don't want to move, they don't want to drop the anchor far away from the coast. That is the problem. And I think for the regulation, we have to take care about this situation and don't have the same situation, you know. I think the mooring and the law is exactly it's a good example for me, and we have to prepare that. For a long time, we think, and we did, we have to do, I'm thinking about to do something for the preservation, for the sustainability, and in particular my generation, you know. We did a lot of mistake with the sea, with the ocean. And today we start to do something. And in Monaco, we would like to prove we are not just talking, but we are doing something. We are doing in a building, because we have the reuse of the water, and also we have panel solar, we have different things like this, and we are working. And also, the Monaco Energy Challenge is a proof. We would like to help the young generation, the young engineer, to change this world. And the first R&B, it was by the Yacht. Do you think about that? You know? Before the R&B, the Yacht was a charter, and I think it was the growth of the R&B, it was a charter for me, if you consider and if you compare something. And I think it's an industry of the luxe, but a lot of boats are in a charter, or a lot of boats are in maybe it's very interesting to continue this conversation. Maybe we don't have the time today, but do you have some other question? Yes, please. Or another point of view. It's important for us to know that. Yeah, thank you. We can start again this conversation.
Yes. Sorry, I think we've gone a bit off track. I mean, it's clearly a very interesting subject, tourism and yachting, destination tourism and yachting. The thing is that this should be another conference in a way. One of the key things, though, from what was mentioned, is the fact that a lot of the developments have to do with the owners taking solutions on board and making improvements into the way the approach is when it comes to design, naval architecture, and basically investing into this R&D. And this is actually why we're here today, is to discuss and find out what's the situation, how technology is making progress to obviously decarbonize yachts and boats and shipping in general, to figure out what's the way forward and what are the various solutions that could be applicable, whether they're applicable to big ships, big cruise ships, or small cruise ships and big cruise ships, whether they're applicable to big yachts or small yachts. And in order to get into the core topics, as I said, you know, we've got a very dense program, and we're already 10 minutes late. I would like to start with a keynote that will be given to us by Keisuke Kimura, who's the Assistant Technical Manager of MOL Limited, and he's going to talk to us about Wind Hunter. Please welcome Mr. Kimura on stage.
Thank you very much. Good morning, ladies and gentlemen. I'm Assistant Technical Manager, MOL. Today, I'd like to introduce our most ambitious and exciting project, Wind Hunter, which shapes the future with wind and hydrogen. First of all, I'd like to introduce my company. My company, MOL, is world's second largest shipping company, and it operates more than 800 vessels, including LNG carrier, pure car carrier, a tanker, bulker, and so on. And our operation covers more than 100 countries. Of course, you know, the decarbonization is the most important thing for maritime sector at present. So we are focusing on using alternative fuels. For example, we are starting with LNG fuel and methanol fuel. And currently, we are developing battery fuel and hydrogen fuel too. These photos are vessel we are operating now currently. And one of the important things for us is wind. Even for commercial vessel, wind is very important to reduce the energy consumption. This sail is developed by my company, MOL, which is a hard sail. And this is a movie of the sea trial of this sail. The height of the sail is 50 meters. And on top of it, there is an anemometer. The sail automatically rotates and shrink and extend depending on the weather condition. It reduces 5 to 8% of energy consumption by one sail. Now I'd like to introduce our most exciting project, Wind Hunter, by the movie.
The Wind Hunter project is a zero-emissions project which aims to leverage the sail technology that was nurtured in Wind Challenger for utilizing offshore wind energy to generate hydrogen, which is clean energy, and supply it for consumption on land. Equipped with numerous rigid sails, the Wind Hunter ship sails with no crew while automatically turning to strong winds and utilizing wind energy to generate hydrogen. It may be described as a mobile hydrogen production plant. The Wind Hunter ship cruises using wind energy, while at the same time generating electricity in underwater turbines. By electrolyzing pure water made from seawater, it manufactures hydrogen. Moreover, by causing a chemical reaction between the hydrogen and toluene, it creates methyl cyclohexane, known as MCH, which is a hydrogen carrier, and stores that in MCH tanks on board. When storage of MCH is continued and the tanks become nearly full, the automatic sailing system is activated. Wind conditions between the ship's position and its port of call are predicted, and the course can be optimized based on hybrid propulsion, combining wind energy and propellers while considering the schedule. On routes where the ship can sail efficiently using maritime winds, the rigid sails are erected so as to capture the wind and enable automatic navigation to start. Capturing the ocean wind to provide energy to fuel everyday life. Harnessing every power to create the future. Creating our future with wind and hydrogen. Wind Hunter Project. Mitsui OSK Lines.
Thank you very much. You can see this movie on YouTube if you like. And this slide shows Wind Hunter roadmap. Currently, we are doing the yacht scale demonstration at the Tokyo Bay area. And our target is to make a large-scale commercial hydrogen production vessel for green hydrogen supply chain. Now, to build medium-sized hydrogen production vessel, 70-meter vessel, we are at the same time conducting a feasibility study and designing it with engineering partner. This is the yacht demonstration overview. Firstly, the yacht go to the area where wind is strong, And secondly, the yacht produce hydrogen by the wind energy using the underwater turbine. And such hydrogen is changed to MCH, methyl cyclohexane, to store on board. And the stored MCH can be transported and unloaded on land and can be utilized as energy. And we've already finished this 1, 2, 3 process. And 4, ground level usage will be conducted around the summer this year. This is the overview of the yacht. Actually, we bought this yacht and retrofit a lot of hydrogen-related devices, such as water electrolyzer, hydrogen sensor, MCH hydrogenation system, and so on the forward side of the vessel. And on the after side, there is underwater turbine generator and the electric propulsion system. And here, I also show the mechanism of the methyl cyclohexane. Hydrogen is combined with toluene by chemical reaction easily. If we extract hydrogen, we need heat, but it's easy to treat on board hydrogen and toluene. So we choose the methyl cyclohexane as a hydrogen carrier. And we obtained the subsidy from NEDO, which is a Japanese government organization. And we are currently designing and conducting feasibility study for hydrogen demand, weather data analysis, hydrogen production vessel specification, and so on for this year. As you know, our final target is to construct green hydrogen supply chain by this Wind Hunter technology. Wind Hunter produce hydrogen and to supply the fuel to everywhere, ships, train, truck, cars, factory, and so on. This is our vision. Finally, this year in 2025, we are exhibiting our Wind Hunter in the World Expo in Osaka. So please come to the Future City Pavilion in Osaka Expo. That's all about my presentation. Thank you very much for listening.
Thank you. Thanks a lot. It was decided there's no time for questions because I'm sure you have a lot of questions, but you can ask him questions during the coffee break. And also, obviously, the subject of how they come up with this technology solution can be discussed further in tomorrow's session, where we also talk about hydrogen more specifically. But thanks again for your great presentation. If you'd like to stand nearby so we can take a photo. Yeah. Quick photo. Thank you. Thanks a lot. Very interesting project. We do hope it comes to fruition by 2028. And before we go back to the hydrogen solutions and we talk about wind and other solutions, especially hydrogen tomorrow, one of the interesting developments recently has been carbon capture. There's been a lot of talk about that, carbon capture solutions, and there's been also some investment by well-known, rich, wealthy people interested in decarbonization, who made some investment into developing carbon capture solutions and implementing them. And of course, it is a promising solution when we talk about decarbonization. But one of the key questions that we have in the nautical world is to what extent is carbon capture a solution that could be adaptable or adapted to shipping, and obviously then to yachting. And so in order to understand how it works and what can be done with it, the panel session that is going to start now is calling on a few specialists to tell us everything about carbon capture and carbon capture on board. And so I would like to call to the stage Mr. Akash Dua, who's a Regional Business Development Director at DNV. If you'd like to, please come and take a seat. Mr. Franck Fourier, who is a Growth Technical Director at SBM Offshore. Dr. Vishnu Prakash, who's the Director of Alethi Arc. Yes, he is here. And Laura Long-Legeloff, who's the CEO and founder of Lang Tech. You should all have a mic. If you don't, it's because it's been a shift. So you just, yes. There's only 4 of you, so yeah. Okay, great. So just to recap briefly how it works, each of them will give a very quick introduction, very quick introduction of who they are, what they do, what they're, and how they come into the picture when it comes to carbon capture. And then we'll start a conversation where I'll have the privilege of asking a few questions first in order to let the experts discuss further. And then we'll have hopefully a few minutes for the audience to be able to ask questions as well. So thank you for giving them a round of applause, and let's get started.
Good morning, everyone. As you see, my name is Akash Dua. I represent DNV here. I don't have a slide to show you, but I have a ship to show you, which is a super yacht Luminare, which is DNV classed. We are one of the leading class societies who is instrumental into all technologies today. And I'm here to debunk any myths around carbon capture particularly, and to answer if it is a silver bullet or not. Thank you.
Thank you. Good. You don't have a slide, which gives us time to further discuss further. Now, Franck?
Yeah. So I have some slide actually. Well, I'm supposed. Here I go. So I'm working in a company doing offshore production platform actually. And a few years ago, we put a lot of effort to decarbonize our production platform. And we come up with, one of the most efficient way to decarbonize our platform was to do carbon capture. So we did a partnership with a Japanese company, quite famous, MHI, Mitsubishi Heavy Industry, which has the technology of carbon capture. It's a post-combustion amine-based carbon capture. And we jointly developed this module that is capturing carbon from the flue gas of our gas turbine, which are used to generate power on board our production platform. So we are talking about train of 300 KTPM in kiloton per annum, 2 trains of them. And one of the, so we have few applications for this offshore carbon capture. We are using it on our production platform, but we are also using it for power barge, which generate blue electron, basically. One of the important things to note compared to the shipping industry is that our platforms are not mobile, so they are fixed, which help in terms of CO2 disposal. Thank you.
Thank you.
It seems to jump to my slides, but okay. Thanks a lot for the invitation here. I feel warmly welcome. I come from Finland, so I think here is about 20 degrees warmer than in Finland at the moment. I hope this picture cools down a little bit. It's from the icy port of Tornio, which is one of our major ports in Finland. We have a ship-owning company, and in addition, a company manufacturing marine components, green tech components. We have started with scrubbers, have ballast water treatment systems, now have been working for a couple of years with carbon capture, have our first carbon capture system up and running, and we can actually change the slide also. So there is a summary of the Lang companies. So all of our vessels are cargo ships. One of them then having a pilot installation of the carbon capture system. It's interesting, you have amine-based. We are basing our carbon capture on using caustic soda, and we can go to the next slide. So then there is a picture also a little bit showing of pilot plant. So the vessel was equipped with a closed loop scrubber already earlier, and then on top of that we have added a carbon capture unit using then caustic soda. And why caustic soda? It is because it's the same chemical that is used already in the SOx scrubbing for cleaning the SOx emissions from the exhaust gases. So then you have one and the same chemical for cleaning both SOx emissions and doing carbon capture. As a result from our carbon capture process, you get soda ash, which is then possible to use as soda ash as a chemical in any further industries. We are having one additional project now ongoing with Damen shipyard, where Damen is installing our carbon capture system on 4 bulk carriers. So not any passenger ships or yachts yet, but hopefully someone gets interested to that.
So that's an actual vessel that's using it, and
correct. That's already on board, installed and up and running since about a year.
okay, thank you.
Hi everyone, I'm Vishnu, as mentioned, and I work for a consultancy based in London. Most of you probably don't know us, but I hope some of you have seen some of the work that we've done. For instance, every year we do a report together with the UN looking at climate action in shipping, where we track progress towards decarbonization. So everything is finance moving in the right way, is technology moving in the right way, are fuels moving in the right way. Beyond that, we do a lot of work with a lot of the big banks and the foundations in Europe, trying to assess climate risks. So if you have a ship or a yacht with specific technology on board, how risky is it in terms of losing value from different climate scenarios or different climate policies that might come into place. And that goes back all the way to when I started working in the industry, where I was one of the founders of the Poseidon Principles, which some of you may know is a benchmark that banks use to track how aligned their shipping portfolios are for decarbonization. But today I just wanted to share a little bit about quite a big project that we did. We started in 2021 together with Stena, which is one of the biggest ship owners in Sweden, and where we actually designed and wanted to potentially build a carbon capture system. And I don't think anyone here really said why we look at carbon capture, so I think it's kind of useful to understand the motivation in the industry for why we think carbon capture might be a necessary solution. If you take any sort of climate scientists and reports out there, in any scenario where we have to limit climate change, there is a need for carbon capture, and there's a need for reusing or sequestering and storing CO2. There's no way we can achieve the goals we have without it. So fundamentally, I think in the next 10 to 20 years, there will be a massive CO2 economy, and obviously that is useful for us as in the shipping to be tapping into, but also something that we can then potentially profit from. For us, for me working for a ship owner, the main challenge was, we all face the same policies, the same regulation across the industry, despite everyone doing very different and kind of important work in whether it's tourism or actually moving kind of critical commodities around the world. So we all have to decarbonize in a level playing field, but we see that to do that we need potentially a lot of alternative fuels, biofuels, and other sources of energy. But we find that we've been seeing that those fuels and those technologies haven't been scaling up as quickly and as efficiently as we'd like them to be. So if we can tap into continuing to use carbon-based fuels, but also then minimize the emissions from them, it is potentially a very useful way to do that. So we had a very ambitious project to build a carbon capture system on a 50,000 deadweight tanker. For context, that is, I think, 600 foot long, so a very big yacht if we ever build one of those size. And we were trying to capture quite a big or significant amount of CO2, and we wanted to get to quite economic levels of doing that. And our initial findings, if I put it bluntly, was that it is, and also if you can move to the next slide, if whoever is controlling it. I think the big challenges that we faced was being the first in the industry to do something is very expensive, and really the only way we can kind of foresee it is either we have foundations or funds helping us fund and show the promise of these technologies. I don't think we got to a point where commercially it made sense yet to retrofit a vessel of this scale to do carbon capture. And the big pivot, I think, we realized was that actually carbon capture might be more suitable for smaller ships and doing very sort of restricted sailing, right? So if you know where the ship is going to be, if the ports are predetermined or kind of within the same region, and then you can tap into existing infrastructure on what to do with the CO2 itself. And I think the still maybe what's restricting owners, especially from what I see, is in going into an investment or going into carbon capture, is that all of the regulation around it, it's still very unknown, right, or undetermined. And we don't know if we should treat captured CO2 even as a waste, or if it's actually a usable product which can go into certain industries. We don't know how to account for it in terms of what one country's CO2 limits might be and how that really plays out. So there is a lot around the technology itself that still needs to come to fruition before we can. Sorry, I will stop here.
Thank you. Well, in fact, a great introduction, because you did tap into a number of questions and you raised a number of questions from what you explained about the project. So let's start, even if you started with, you talked about regulations and where carbon capture stands. We'll tackle that aspect afterwards, if you don't mind. Because first, I'd like to understand, I mean, let's say, pretty new into that technology. And when you do develop, and you've developed solutions, whether it's SBM offshore or Laura, you've developed a solution on board a boat. Technically, how complicated and how much space does it take to actually have a carbon capture refinery plant on board?
If I may start here, so having both the ship owning company and then the marine components production company owned in the same family group of companies, so that of course puts us looking at the product development from the ship owners' point of view. And their important factors then are that the components cannot be too big, they cannot be too heavy, they cannot take cargo space, and they also need to be simple enough for the crew to use, not technically too complicated or risky for failures. So that's why we then, in our case, dropped the amine-based scrubbers, because we were of course looking at amine-based, and they have probably been land-based use. Amine scrubbing is pretty well known anyway. So to keep it on board is very much space consuming, and then also technically rather complicated. And you have to use a lot of energy to then again separate the CO2 from the process water. And then again, now when we went for using caustic soda, this actually comes from our knowledge from the SOx scrubbers, that if you have a too strong concentration of caustic soda in the SOx scrubber process, then this starts to react with CO2. Yeah, back in the years when we were developing the SOx scrubbers, this was of course a reaction that needed to be avoided the best you could. But then in the carbon capture process, then again we turned it to the opposite way and did our best for the reaction to happen. So first, on this pilot vessel, the SOx is neutralized in the SOx scrubber, and thereafter is a second washing process with a stronger liquid of caustic soda containing process water, and this then reacts with CO2. We can reach up to roughly 50% carbon capture of that exhaust gas amount that is fed into the capture unit, the CO2 reactor. and because we don't do any separation on board of the processed water, so that then reduces the energy consumption significantly, and okay, it adds a little bit of the storage need, what you have to store in the tanks on board a vessel. But as you already mentioned, so it's carbon capture at the moment, it is absolutely best suited for vessels that have short sea legs. For instance, this vessel where we have it is maximum 4 days at sea, and calling regular ports in the Netherlands and in Finland. So there we can, as one of the first vessels, I guess, where it is up and running, so then we can arrange it in these ports, the offloading of the soda ash then.
Thank you. Frank, you have something to add to this in terms of...
Yeah, I mean, I agree. It's quite complex. And the reason why we want to amine-based solution, it's exactly the reason why you didn't go there. I mean, we are fixed, and we are on the oil production platform with a very complex system already. So we have people on board that are used to run this type of system. So for us, it was not, I mean, the technology gap or the technical gap is really minimum. And we want to amine-based because it was the most mature solution at the time and the most efficient. I mean, we are capturing 90% of the CO2 from the flue gas, so it's quite efficient. And I agree with you, the energy that it demands can be quite significant, but for us being offshore, producing gas that we re-inject, the energy is not such an issue. Just in terms of CO2 emission, that's the only matter. I mean, in terms of energy as a cost, it's not so much a problem because we have plenty of gas that if we don't use, we re-inject anyway. So I think the reason why we moved to this solution is I can see that it is not a good solution for a ship that is moving. And yes, it takes some space. I mean, just to give a few figures, our 300 KTPA module is 25 by 28 meter and 3,000 tons. So that gives you a bit the science of the space that it takes. So it's clearly not applicable for shipping industry. We start to see some smaller units that could potentially be used for shipping. But I mean, the challenge I think will be the CO2 disposal because you need to, and that's probably where you limit, the number of days at sea that you can have this system up and running because the amount of CO2 that you recover, I mean, you have to do something with it.
Thank you. Before we get onto these technical aspects of application to yachting, possibly or not, to discuss, well, let's have a look at the regulatory framework because obviously there's a lot of gray zones to say about what's happening with carbon capture and especially carbon once captured.
Actually, I'd like to say it's not a gray zone, it's an absolutely white zone. It's everything to be written at the moment. So this is good news, actually, in a way, because things are developing. There is no confusion there. If you look at where this is coming from, I mean, the starting point of this is basically the Paris climate action, where we sort of challenge the world to reduce the emissions and make sure that the temperature drops. That's where it came from. And then regulations such as GHG, IMO GHG came in, Fuel EU, EU ETS. If you've not heard this, if you've not heard Fuel EU Maritime, I'm pretty sure you're not dealing with the commercial aspect of shipping today. I must admit, there are no regulations neither on the ship side nor shore side at this moment that direct the capture bit. And this gets very interesting. The regulations that exist today are basically dealing with the construction of the tanks where you could store the carbon capture. The technology that you're developing can also be certified and made safe for use. But at the same time, there are no regulations today on the port side, how to receive this, the connections that will be used to receive this. So once we get into that bit, you will require standardization of these tanks, which are currently following the IMO regulations for standardization. You will require the standard protocol on purity, because CO2 without purity is no use to anything, really. You will require the infrastructure to be developed. That means like LNG today on board, you will need standard connections to bunker and debunker this CO2 which is captured. And at the same time, I think before even we go ahead, I would like to also sort of, I might sound the devil here, but I want to put it through. I think it's important for us to know what to do with this CO2. That's the most important question. And some of you may have heard about Northern Lights project. This is one of the flagship projects, but there are also other projects which are happening. And I want to give you a bit of an understanding on the magnitude. The current capacity of the Northern Lights project is 5 megatons at the moment. If every ship on board in the world, and this is, I can share the publication with you, installs a carbon capture unit and just captures 20%, you will go to more than 1,000 gigatons, 1,000 megatons, 1 gigaton, I'm sorry, 1 gigaton. So we are not built today for capturing and storing this CO2, because without storage, this capturing is no use. So I think we need a bit more development on the infrastructure side to capture and then store it, because capturing without storage will not really solve anything for us at this moment.
Thank you. So we're clear on regulations, easy, it works fine. And as you said, and I could see that from your slide, and you were mentioning as well, Vishnu, is once you've captured it, you store it, whether you can store on board, and then you need to remove it, obviously, to make use of it. So what are your views, all of you, Vishnu maybe, to start with, on what's the best way forward if developing that usage of carbon capture?
Sure, if I could start, I think there are potentially plenty of use cases for it. So if you think of a new fuel like e-methanol, so methanol made from green hydrogen, you need CO2 as an input, and that CO2 ideally has to come from a recycled or biogenic source, so in order to certify it as green. So, you know, as these fuel supply chains evolve, I think there are opportunities for recycling and using CO2. In terms of sequestration, I think there is I don't personally have a view on this, but I think depending on who you ask, some people say it's very safe, and if you put it underground in existing oil wells or depleted reserves, you can store it permanently. As an example, I was in Texas presenting at the University of Austin, and one of the professors who's been looking at carbon or sequestering CO2 complained that she's been staring at these CO2 fields for 10 years and nothing has leaked and nothing has come out. So, whereas if you're in Europe, I think the sentiment is very different, or at least not as developed. So we do have indications of what the cost might be of moving and storing CO2. So it ranges from everywhere from a few dollars per ton to hundreds of dollars per ton. And a lot of the oil majors are developing options for moving that. I think it's like any other resource or solution that starts, it's all fragmented, it's very geographically spread out. So it's not easy to go and drop CO2 off yet, right? But I think the more and more we realize we need CO2 in some contexts, I think those chains will develop, but it's too slow at this point, yes.
Thank you. Laura, you obviously have a pilot project, and Scandinavia, generally speaking, is very much ahead of everyone when it comes to developing these alternative solutions for decarbonization. So what do you do with your carbon?
Yeah, in our case, as mentioned, caustic soda reacts with CO2, it turns into soda ash. And this is actually then replacing fossil-based soda ash. So the market price of soda ash produced in, so to say, recycled way of captured CO2 has a higher market value than actually. So when we buy the caustic soda for doing the carbon capture, then it balances quite well out. So economically, it also, OPEX is quite well handled there, that you can then sell the soda ash to a roughly same price as you buy the caustic soda. And then other uses, if it's not, EU now accepts chemically bound, permanently chemically bound, which is then our case. And then if it is carbon capture where the CO2 is separated from the process water or whatever, based usually then is separated CO2. So there I have exactly the same opinion with you, Vishnu, that doing then further e-fuels, using it for methanol production, for instance, we have to get rid of the fossil fuels, and then CO2 becomes anyway a needed chemical for producing these new fuels. So in my opinion, there is also not only the need to store it permanently, but really then to use it instead of fossil sources of CO2. And then, of course, we should do carbon capture, even though whatever vessel or cruise ship or yacht is burning green fuels or e-fuels, so still do carbon capture from that. Keep the CO2 in a continuous loop.
Thank you. Frank, in fact, you mentioned something about the fact that the systems you developed, you said it's complicated and everything, but you worked on, or you looked at having them in smaller units that could be applicable to shipping. And then to what extent do you think, and all of you think, that these smaller units or these developments could actually be at some point be of use within, okay, let's say large yachts? Do you see that as something that can happen, may happen, will happen, or will never happen because of other solutions, or simply because it's not economically viable, it takes too much space, it's not worth it, whatever?
But yeah, I mean, if it's ever happen, I think it will start with the large ship probably, because for scaling down this, I mean, it's feasible. But I think the challenge. The challenge are not so much technical. They are more, for me, economical. I mean, today, and it's back to regulation, but more on carbon tax issue. I mean, today, there is a value with the CO2 that we capture from fossil fuel, and we can valorize that, then things will happen. Today, we have some technical solutions that exist, and it's very difficult. It's a challenge to sell them, because it's just not economical, and we are not, if we look at our case, we are not bringing any value to our client except that the management of the waste. If they don't have to pay for this waste today, the incentive for them to manage or to invest a large capex to manage this waste is not there. So we are counting on the internal policy of the whole company to do so. But the reality is that this will happen the day regulation will impose this. So carbon tax, and country where we operate will need to have a system of carbon tax that will make this happen. Oh, that's my view.
Thank you. Then Akash and Vishnu, your views on this question, and then we'll leave it to the audience to ask a few questions.
Yeah, just to complement what was just mentioned, I think, and then specifically to small vessels today, we need to appreciate the size of the carbon capture technology that we have. For yachts or anything even of the size of Luminare, you will end up taking almost 1 to 2% of the deadweight capacity. And that means for a cargo owner, that is a loss of capacity unless you are able to find an economical medium of earning it back. 10 to 20% of more fuel usage or capacity of the engine to be able to trap that CO2, that's another aspect. And then depending on what you're using, if you're using amine-based, you again will have the efficiency of amine drop down. So every few years, you'll have to replace that. That's an economical aspect you need to cover together before even taking it further to even, I would say, cruising, not cruising, the cargo ships. But at the same time, we also need to appreciate what's happening in the environment that we are living in the EU at the moment. It's cheaper to pay EU ETS or cheaper to buy credits than to install that technology and operate it. And that's a shame, apparently. That's a big driver, or let's say a misdriver today. It may get expensive with time. I'm pretty sure there'll be enough conflicting in the market, enough trading happening. So with time, that may develop for us. But today, I think, and a lot of ship owner friends of mine will hate me for saying this, but the EU ETS cost that we have today doesn't appreciate enough for CCS technology to be viable, especially till either the technology comes down in cost or capex, or the fuel requirement to operate that technology goes down in amount of energy usage, or at the same time, there is more credits for carbon capture and storage, and also capacity building, which I already told on. Thank you.
If I can add just quickly, I'm an economist by background, so I think the way that I look at decarbonization in general is that you should spend your dollars or euros where it has the most impact in reducing CO2, right? Or whatever emissions you're looking at. And at this point, I think I concur with the rest of the panel, like the cost of carbon capture per ton of CO2 reduced is still quite high. I think you've reduced it quite a lot, Laura, but if you had a limited amount of money and you wanted to make the biggest impact on the emissions, it's probably not where it needs to be today to work. Having said that, I think what's interesting and important, I think, to follow is you have this global regulation that EU or let's say the IMO produces on reducing emissions, but you will also start to see pockets of localized regulation, right? So in certain countries, certain waters, where there might be a greater incentive and a potential to use carbon capture solutions. So depending on how that evolves, it might obviously still have a role going forward.
Thank you. Thanks a lot. Please stay here. We have already one question. I can only have time for one or two questions, so please.
Yeah, I'm Daniel Chatterjee from Rolls-Royce MTU. So first of all, I'm convinced carbon capture will play a role in a larger maritime and maybe energy stationary context. I wonder, because you elaborated a bit, okay, we need to define how it's sequestered, which for sure we need, and then there was the economic piece. And a bit from the learning, at least we take from the ramp of the hydrogen sector, where we define how is the greenest hydrogen, and at the end, nobody has a business case to produce hydrogen at the moment. Do you see it maybe could be an intermediate step, and you a bit elaborate that it just say, okay, we take CO2 out of those processes, and we just replace something we have. It's not CO2 neutral, so if, for example, we have a stationary plant in UK, we sell the CO2 we capture to a beverage industry, and there's a business case for our customer. So just maybe this time try to ramp up the technology, but not in the first instance to be CO2 neutral. Could that maybe help get regulations and technology ramp up?
Go ahead, Frank.
No, I agree. I think, and we look at that, but you still have the, I mean, we look at CO2 usage, so, you know, valorizing the CO2 that we capture, but as you mentioned, I mean, the amount of CO2 that is produced daily for energy generation is just huge, and is way above any usage of CO2. You know, you are talking about gigaton, but it's exactly this. One of our oil production platform is producing 600,000 tons per annum. Sorry, and there are 100,000 of those worldwide. So we are talking about gigaton of CO2 that we have to do something with. So sequestration, I mean, usage, we don't have enough capacity, I mean, demand for usage of all this CO2 that we will eventually capture. And sequestration is also an issue. I mean, you mentioned Northern Light is 5 MTPA. Yeah. We have Artemis, the port. But all those, they are not covering the quantity of CO2 that we can potentially capture. So, and then to answer your question, we will come into competition with e-fuel. At one day, at one stage, I mean, people will go where it's easier and cheaper to decarbonize. So we have to ask ourselves, do we want to have fuel that are without carbon and produce energy on board? And for a shipping industry, it does probably make more sense to capture the CO2 before you send this energy fuel. I mean, this fuel on board of shipping moving object instead of capturing on the moving object. So we will go in competition with whatever is emerging. As you say, hydrogen is still quite immature, but maybe in the year to come, other alternative fuel like ammonia or e-methanol may play a role indeed. But at the end of the day, it will be a question of cost, I think. Sorry.
Can I just supplement his answer? And at the risk of not sounding pessimistic towards the technology, I must say, this technology will coexist with other saving mechanisms on energy. I mean, we cannot ignore it because, as you know, most of the ships have a life cycle of 25 to 30 years. I'm now thinking more towards ships which are between 17 to 18 years old. if they need to exist and sail on waters and be commercially viable, they probably will need carbon capture technology on board. And that's the reason why it coexists today amongst all other energy efficiency measures, just to make sure you can reduce your EU ETS and in future fuel EU burden. And then IMO net zero strategy is also coming through in October, most probably coming through in October. And that will also then sort of incentivize installing something like this. So that would be my 10 cents.
Thank you. One very quick question, please.
Yes, well, thank you. Guido Loef of FedChip. I've been looking at carbon capture as well. Storing well, carbon, CO2 in a superyacht, that will be very difficult. I mean, if we talk about money, so do you want to give away all that precious luxury space for storing CO2? I don't think so. It's not going to work. Now, it's all about I guess it's about this economy of the fuel. So I was hearing about that before, looking at the gas production platforms. I mean, they emit pretty much the same amount as the entire shipping fleet. So let's start there, because you can inject into the field, right? Which makes sense. But I wonder, so if you look at other maritime realms, is it viable economically wise compared to other areas where you can capture carbon?
I would say that it's okay, we already said that it's not yet in the regulation that you could take carbon capture into account, but it's coming from the regulation, of course, that ship owners have to do something for their cargo vessels. You have the CII, ETS, Fuel EU, so this is forcing owners to do something, and carbon capture is, especially for existing vessels where you can maybe not change the fuel you are burning, so carbon capture is one of the most potential alternatives, in my opinion.
Yeah, I agree, and it depends on when you ask this question. If you ask this question today, the answer short is no. It's a bit more expensive than burning commercial normal fossil fuel at the moment and just paying your ETS burdens. That's currently the case. But again, I go back to the vessels that I'm mentioning, 17, 18-year-old vessels. They probably are more expensive to fit with retro e-fuel solutions or even any other alternative fuel solutions. At the same time, there is the non-availability of alternative fuels. I mean, we are talking about all these carbon neutral fuels and injecting the CO2 and getting better fuels and so on. But let's also appreciate what is available. And probably things may change in 5 years' time, but I would like to think it's a chicken and egg problem. Once we solve the chicken, we will have the egg. And that's where I would like to conclude by saying, I think today it may be a little more expensive and it requires a lot of capital expenditure and also thought process into really banking it. But you do get benefits in terms of ESG, in terms of your reporting. It depends what you want to portray in the market. Do you want to be a front leader or a follower? And most front leaders would probably coexist with this technology while they use the others as well.
Thank you. I think we can end on this note. Obviously, during the coffee break, you can continue the conversations individually. It was brilliant. Thanks a lot for very enlightening as well. Not so optimistic or pessimistic, but let's see how things move forward. At least now we understand better. Thank you very much. Please, if you take a step forward for the photo and give them a round of applause. Thank you. Thanks a lot. And so without further ado, I'm asking Jacopo Senaraga from Azimut Benetti Group, who's the R&D project manager, to come on stage so that he can also give us a short keynote. Welcome, and please give him a round of applause. And you should have that mic.
Thank you.
And that's
working? Yeah. Thanks. Good morning, everybody. It is absolutely an honor to be here. I will not introduce Azimut Benetti since I guess that you already know our group. Today, I would like to give you an overview on our approach to product sustainability and to give you a glimpse of our interpretation of the main trends that for sure that will be deeply discussed today and tomorrow in these conferences. When we speak about sustainability, in particular concerning to the use phase, these are the main topics that we have to tackle. I will show you some of the projects that we are working on concerning these topics, but we also have the clear view, and in our vision, we think that we have tools to manage these challenges, and they are strategic partnerships and shared rules in the industry. I will start with naval architecture. Over the last 20 years, we gained a quite important experience in developing efficient hull shapes for a wide variety of both sizes and types. In our process, the CFD simulation are fully embedded, and we use them both for power prediction optimization and seakeeping performances simulation. We decided to make a step forward, so we started an agreement with Alvane. The stern foil designed and developed by Alvane has a wide variety of benefits on board. The first one, the more important, is that it reduces the resistance in a wide range of speeds, at low and medium speed, very close to cruise speeds, and also some side effects, such as the reduction of pitch motion, resulting in a better comfort on board. As part of our partnership, we will develop, build and install a bespoke carbon fiber foil that will be installed on our Azimuth Grande 44 meter that will be launched next year. Coming to engine and propulsion, our research covered a lot of propeller optimization, and especially for smaller and faster boats, we focused a lot on pod propulsion. We have a long-term relationship with Volvo Penta, with IPS. 3 years on our Azimuth Grande 26 meter, we launched the first ZF large pod 4600 series. And this September at Cannes Boat Show, we launched the bigger brother of this pod, so the 4900 system. It will be part of an integrated solution developed in partnership with Rolls-Royce. The main advantages related to reduction of emission is about the higher efficiency in terms of propulsion compared to a standard shaft line, but also enhance better maneuverability, especially at lower speed, and reduced vibration. The system is hybrid ready, so it's suitable for addition of electric motor. And we are looking forward to starting the sea trials in the next months to be ready for September. Electrification. Electrification is for sure one of the pillars of our strategy. We started more or less 19 years ago, in 2006, with Ambrosia, the first hybrid electric boat that we built in Benetti. Over the 20 years, we launched several projects. We developed several systems, both for Azimuth and Benetti models. But today, I would like to highlight what we did last summer. In partnership with Volvo Penta, we launched our Azimuth Sidex 7. That was the first boat to be equipped with the full hybrid system integrated on IPS. The boat is equipped with 2 electric motors of 160 kilowatt each, has a battery pack of up to 400 kilowatt hour, and the system allows us to sail up to 11 knots in full electric mode. We got rid of the generator on board, so we rely on batteries for all the hotel loads. And in order to guarantee a sufficient reliability and operability of the system, we are able to charge the battery really fastly. In 1 hour, we are able to collect all the energy needed for 1 night with air conditioning on and seakeepers on. Of course, due to the wide range of boats that we build that are part of our fleet, we cannot rely only on one system. So we developed our 4-level of electrification strategy that is based on a modular approach that improves the complexity and also the features of the system based on the dimension, of course, of the price of the boat that we are installing the system on. Starting from level 1, where we have batteries for peak shaving and enough battery also to guarantee at least 4 hours during daytime and 8 hours during nighttime with the genset off on board on our vessel. We go up to the 4th level, that is the full hybrid, that is present on Civic 7, but also on several Benetti model. For sure, you will hear a lot about alternative fuels tomorrow in the conference. Just I want to give you an overview on our approach from our side. We completed a study 2 years ago with Polytechnic of Turin, taking into account all different fuels that are feasible for our yachts. And after the results of this study, we developed our roadmap. We are working on a methanol project that will be launched and be ready in more or less 5 years, when we expect that methanol will be widely available, at least green methanol will be widely available. But for now, and starting actually 2 years ago, we have been pushing a lot on HVO. I'm sure that you are well familiar with HVO. HVO is a plug-in fuel, stands for hydrotreated vegetable oil, is fully compatible with all existing engines and gensets, so it's a plug-in fuel, and has the big advantage that can reduce CO2 emission from well to wake up to 90% compared to standard fossil diesel. In May 2023, we started a partnership with Enilive for the supply of HVO for our internal sea trials and commissioning activities. And in nautical year 2023-24, we used about 700,000 liters of HVO for our internal operations. Starting from last Cannes Boat Show, we worked together with Rina to add to our boat also the additional class notation HVO that certifies the full compatibility of our boat with the fuel also for our clients. Last but not least, the hotel loads. Especially for super yachts, the time spent at anchor or in harbor is about 90% of the entire life of the boat, so we have to tackle hotel loads quite strongly. So we have different projects dealing with all the main consumers on board. We signed an agreement with a supplier of direct air expansion HVAC systems that can help to reduce a lot the energy consumption on board. We have an heat recovery system for generators, for example, to heat the water for the pools, reducing energy consumption from the boiler. And we are working on different preset scenarios that help the master and the crew to have an easy access to the most efficient way to operate the boat without affecting the comfort on board. Furthermore, since we really believe that there is a lot that we can do about hotel loads, we have several projects creating digital twins based on IoT for different sizes of boat. Consider that for a 40-meter boat, a standard serious boat from our fleet, we have more or less 1,000 signals available already without adding any additional sensor. We are now focusing on 100 of them, more or less, just to be able to manage them easily. But we really believe that while by experience we can easily understand that the correlation between the set point of the air conditioner, the outside temperature, and the consumption of the chiller is something that we can understand quite easily. With this amount of signals, we think that an AI approach, so an AI analysis of data based on data clustering, can help us to understand better the actual relationship between the actors on board of our yachts. I will close the speech with one thing that we really believe on. We are sure that we have to build together the rules and the regulation about our industry. We are proudly part of all the main joint industry project, starting from C-Index. Natalie is here today. And our commitment on this project for us is very important because we think that is what we need to make a step forward in the credibility and also the maturity of our industry. And at the same time, we believe that is necessary to build the playground for all these students, these enthusiastic and passionate students to express their potential. Thank you. Thank you very much.
Thank you. Thank you, Jacopo. No questions for you. Discussions during coffee break, which is going to be probably shorter than expected. But thanks a lot. What's interesting is that over the years, you can see that the variations of, or the multiplication of solutions to address each and every aspect of operations of a yacht have been taken into account by the builders, by the architects, by the engineers, so that they can address especially hotel load and obviously naval architecture, improving efficiency, which is good that everyone is really embarking on these to make things better. But one thing that we don't often talk about, and we're going to talk about it with the next panel, is noise pollution. So before we get onto the noise pollution panel, and I call on the panelists, please give Jacopo a round of applause, and please stand in front of the picture. Thank you. And so before the coffee break, for the next session, we're going to talk about marine noise pollution and the impact of noise, something that we haven't touched upon at the Energy Boat Challenge conferences so far, but which is obviously becoming more and more a serious problem, and a problem that more and more people are obviously becoming more aware of. So the idea with this panel session is to look into what we track, what data we've got, what impact noise pollution has got on sea life, and what solutions we may come up with if we don't have them yet. So for this panel, I'd like to call to the stage Eric Baudin, who is the Innovation and Environment Products Manager at Bureau Veritas. Thomas Folgo, who is the Director of Innovation at Quiet Oceans. It's all in the name. Nathalie Kever, who is the General Secretary of the Sea Index. Wassim Daoud, who is the Head of CSR and Sustainability for Ponant Company. And Jérémy Lagarigue, who's the CEO of EODev, Energy Observer Developments. Thank you, gentlemen and lady. So as I explained before, a couple of minutes for each of you, I don't know who's got slides or no slides, to briefly introduce yourselves before we can start the conversation, first with my questions and potentially with the questions from the audience afterwards. Thank you and welcome.
Yeah, I think I'm first. Happy to be here.
It should be in the order, yeah.
Yeah, thank you. So working for Bureau Veritas, I felt committed to present you a very quick overview of the context, the regulatory context. We have observed an evolving regulatory framework for underwater noise these last years, with an acceleration the last 3 years, and upcoming commitments for the next 5 years. If you go to the next, please. What I like you to retain today is the present situation and a key important elements. Two technical ones, the finalization of the ISO working group on underwater noise measurement on shallow waters, which is an essential piece for characterizing ship signature, and also the recent progress of the technical group of the European Commission that has to implement the Marine Strategy Framework Directive for underwater noise. Most recently and importantly, a few days ago in Nice, during UNOC, a high ambition coalition for quiet oceans has been signed by 37 countries. This is a strong and clear message that echoes the IMO guidelines and implementation of the experience building phase that is running up to 2026. Next, yes, please. And these guidelines for ship owners are quite straightforward with 4 pillars. Do your baseline, measure your ship underwater noise signature, set your ambitions, align your strategy with the available solutions and mitigation strategies, and monitor the efficiency of these strategies. But what is also very important in such non-mandatory framework is the incentivization. And this incentivization needs tools, to facilitate the uptake and needs methods. And that's where I stop here and leave the floor to Thomas to present 2 key incentivization components.
Thank you. Indeed, we talk a lot about taxation and incentivization, but I'm sure there'll be some more discussions about that. Yes, please, Thomas.
Yes, good morning, everybody. Thomas Foligo from Quite Oceans, and thank you, Eric, for the introduction. We've been asked by the European Commission through the PIACO project, which is to develop practical solutions to help the ship owners in being quieter. And we have developed an index, which is the Noise Ship Index, which should be applicable to the commercial vessels, but also to yachts. It is a system that will help. It's a process and notation that will help the ship owners to progress on the issue. So it rewards every action that is taken towards quieter vessels and quieter operations. So by following the 4 different pillars we have in the Noise Ship Index, the ship owner is able to make progress and will be rewarded for every step it does, every milestone he will achieve. There are management and empowerment actions that are rewarded. Diagnosis, because the ship owner needs to know where it starts from and know how it can progress from the technical point of view or from an operational point of view. And then when we start to achieve some reduction from the baseline, from the initial point, then there are some rewards. And if you are compliant with the class society's criteria, then it means that you have achieved being quieter. Next one. The second stone we have developed in the PIACO project was to develop a buoy, which is called Smart URN, URN for underwater radiated noise. It's a semi-permanent station, measurement station, that is placed either on strategic places, like we did deploy it offshore the harbor of Fos-sur-Mer, where all the vessels have to sail in front of the buoys, and the buoy is automatically measuring the noise of the individual vessel and calculating how much noise the vessel introduced into the marine environment, and then store that. And based on that, we can do some more analysis. It has also been deployed offshore the Genova harbor for some months, and it will be redeployed in the North Sea and in the Med in the next years. It is a starting point so we mutualize the cost of the buoy because we can measure multiple vessels per day. So it's also a good solution for shipyards who wants to certify the new vessels built with a certain level of noise. Thank you.
Thank you. So this is where the C index comes in. So we're proudly announcing the fact that Bureau Veritas C index have an ongoing partnership. It's been a year in the making. As most of you who are familiar with the C index, we've been focusing on CO2 emissions up until now, energy intensity. But from the very origins of the C index, we always knew there was a correlation between underwater radiated noise and the energy intensity of the vessels. So about a year and a half ago, we started conversations with Bureau Veritas, and now that's where we're going to leverage our collaboration. Also with Quite Oceans. Again, it's all about raising awareness and achieving the next stage. If I could have the next slide, please. Thank you. And so basically our action plan is to adopt the initiative that already exists for shipping and to adapt it to super yachts. We've always believed that we need to align with IMO methodologies because as the regulations are coming, there'll be more scrutiny if things are not aligned. So this again is another segment that we're adding to the C index, which is also aligned with the IMO. And so we are now in the process of comparing the different analysis and the different segments of the program to super yachts. Obviously, things are very different, and so these 18 or 19 points that we're going through one by one to be able to adapt them to super yachts. Additionally to that, Thomas and Eric talked about the baseline, which is very important because, as we did for CO2, we have to create a baseline, and so we have the project here in Monaco. It's still a long way off, but to have that baseline created specifically for yachts, so that we can move together with that. Voilà.
Thank you. And we'll talk about rewards afterwards. All right. Thank you, Vasim. About Ponant. Sorry, you don't have a slide. So
yes, I do.
Oh, you do. Okay. So then there must be a change in order. There you go.
Okay. Yeah, good morning, everyone. So Ponant is a French cruise line, luxury one. We have already 20 small ships with new river vessels. And of course, for us, the comfort of our passengers is very important. So the question of the noise is included into the design, since the design of the ships. And I have to add to the 3 goals of Bureau Veritas, the first goal, I think, is to include into the design before the measurement. It means that you have to think about it, because it's to anticipate the noise and the vibration impact. Because we talk about the noise, but sometimes we also have to include vibration, because we think also that even if we are in the sea, we have impacts on shore due to the vibration also. So for us, it's an important topic, and we are known to be respectful about the nature and the wildlife. Maybe the second slide, please. So concerning the mitigation and innovation, as I said, we include the noise and vibration into the design. We have the first class of vibration and noise of Bureau Veritas, and we have also zero noise navigation, zero noise and emission. With sails and batteries, we have a boat with sails and another one with batteries, so we also include that in sensitive areas. And we have 7 ships fitted with hydrophones, and we are also include different noise measurement. Already one signature of UR onto Jacques Cartier, one Explorer ship. And now we are working in a zero emission ship with zero noise, the Swap to Zero project, of course, for the zero carbon footprint, but also we include all the emission, atmospheric emission, and waste, and the water emission also, and of course the noise. So now we are especially working in different scientific and R&D projects to know and identify the relation between animals, noise, and vibration. Thank you.
Thank you. Well, since your slides were before, then you'll have to wait a bit more, because I already have a question for you. The question basically, not for you, but for all of them, and especially for Vasim. From your experience, since you've started implementing solutions on board, and you could see from the graph there's some improvements, right? What are, at this stage, the best practice, the best mitigation measures that you've experienced? I mean, can you already give advice to, there's obviously yacht builders here, on what can be done already to make it better?
Yeah, as I said, we worked on the design of the hull, the propellers, and also the choice of zodiacs and small tenders, because I didn't spoke about that, but we also include the zodiacs for the noise impact. But I think that the best measures are around the protocols. It means that the reduction of the speed, the switch of the engines, as I said, for vessels and also for zodiacs. When we are in remote areas, we switch on the engines to be really in silent mode.
Okay, so propellers and engines obviously are the key and the obvious ones in a way, and the hull configuration, but without impacting performance, or
yeah, they're not the performance, but I think as I told you, there are other measures like the speed and also the protocols, how we operate, not only the technical aspect.
Okay, thank you. You wanted to say something before?
Well, yeah, maybe it's very true. Operation is also very important because the sound propagates differently according to the marine environment properties. If you have high temperature, if you have high salinity, or low temperature, low salinity, the sound is going to propagate very differently. So, and the bathymetry plays also a role. If you're in shallow water, in deep water, propagation of the sound is going to be very different. The sound can propagate very far away around the vessel. And so operational measures that will slow down, for example, in places where the propagation is very good, and maybe you can go faster in places where the sound is not propagating very well, can be a way to optimize and reduce the footprint of the vessel.
Okay, well, that was actually kind of the answer to my next question. So, great. I mean, in terms of the impact, are you able today to actually measure, as you said, the propagation of the noise and the impact it has on the marine life depending on the environment? And how do the yachts or the boats actually adjust to this to make it better? Do you have already some existing experience or feedback to give on that, or is that still work in progress?
No, we are quite mature on that because we can model actually, so we can use the measurement that would be done in situ for the baseline, and then use this data and model actually use the profile, the operational profile of the vessel, and use that and really model and assess what is going to be the average footprint of the vessel. And then we can analyze the places where the footprint is very high and places where it's not very high, and use that to optimize the profile. Okay. According to also the other constraints for the commercial operation, of course.
Okay, you wanted to, yes.
Yeah, and regarding the impact itself, we have worked in all these research projects in tight collaboration with bioacousticians and biologists. And we are working really tightly. They are working on what are the impact on the species, and we are working on the solutions and the assessment, and we will couple when we have more knowledge. But we are not stopping at the step of saying, okay, do your job and come back with all the knowledge on all the species, because otherwise we will wait for 100 years.
Thank you.
Can
yes,
I just,
quickly.
Just asking the impact, and you were talking about bioacousticians, and our friend Michel André, I had the conversation with them saying, okay, so where do super yachts are situated in terms of the noise emissions? And what he said to me was, in high seas, of course, the yacht's impact on underwater radiated noise is not going to have much of an effect. It's on the coastal areas, which is the most, what he said to me verbatim is, this is where yachting added to the shipping has the potential to break the camel's back in terms of biodiversity. So it's really, and there are studies out now. There was a study about a year ago, coast of Mexico, and they were studying whales, and the coastal effects are quite devastating with underwater radiated noise. So no, super yacht is not it's not the cause of the underwater radiated harm, but it has the possibility to la goutte qui fait déborder le vase, quoi. Voilà.
Yeah, and there's obviously more yachts in the area than big shipping vessels making noise, right?
It's the coastal areas where yachts are, yeah. Thanks.
So I'm going back to Jeremy. You can, yeah.
But before the slide, I think the most important slide we can see is the boat just downstairs. We have the Energy Observer vessel. That was the first boat going around the world with a zero emission solution, zero noise. And that boat made plenty of measure, because when we speak about noise inside the water, I think it's important to consider that it has an impact on the wild, but we have to consider some numbers. And basically, we can consider that from 1 kilometer from a boat, some vibration can be have a huge impact on the wild, and can also destroy some of the here's opportunity of some fishes. So that's why it is so important, if we want to protect the wild into the ocean, to try to create some solution in order to be quiet into the ocean. And that was one of the points of our vessel. It was not only to be a zero-emission solution, but also to be as quiet as possible. And from Energy Observer, we create a company named EODev, which I am now the CEO of the company, and we are offering several solutions that maybe I can share with you. One is a power generator. This is for on-land solution, mainly used to charge boats on the dock on the big harbors that do not have yet the grid connection. It's a zero emission and quiet. The second one is a battery solution that can be installed inside boat, but also onshore. It can be parallelized with diesel, and I say that mainly what just Azimuth and Benetti presented few times ago, it's sort of hybridization in order to optimize the efficiency and also the noise. And hydrogen range extender. On the next slide, you have some pictures about what we have done. And most of that, you are more than welcome to see and visit the Energy Observer boat downstairs. Basically, today we're offering a decarbonizing solution, but I think the biggest impact we have today on top of the decarbonization is also the noise. We have seen today some of the students coming with a sort of new ideas of propeller named a toroidal propeller. That propeller exists since 20 years. And in 20 years' time, no one was considering that propeller. And now all the new, very complex and strong computer are saying this is the best propeller. And we can measure today at least 50% noise reduction inside the water just by changing the propeller. And everything is a question about vibration, frequency, and amplitude. And that's why having all the solutions that can create energy without movement is key to try to reduce emissions. So for sure, the battery, for sure, chemical reaction with a fuel cell, it can be a PM or SOFC, the two are working. But as some of my colleagues present a bit before, those technologies are today ready on the market, but not yet competitive in CapEx and OpEx point of view. And also, if we have a hydrogen vessel here, we cannot charge in the harbor of Monaco. So that's why it's a bit struggling to develop. But maybe the best example I can share with you is the slide of the elevator we have in the mine industry, because we have more and more battery. We need more and more lithium. The biggest impact is that we have bigger and bigger mines around the world. And today we are world leader in developing the battery for those solutions. And by implementing the battery inside those, we decrease the temperature inside the mine from 20 degrees. We divide the noise by 10. And we divide the, let's say, the injury or the accident inside the mine from 80% because of the reduction of the noise. And just for the human, so you can imagine if we can divide by 1,000 the noise inside the water from the wild, I guess we are all very touched if we see a whale going into a harbor or going into a beach, and we do not want to see that anymore. So by having those solutions, we can divide by more than 100 the noise inside the ocean. And that's why I think we all have to have a path to consider that for the wild and the protecting the biodiversity.
Thank you. Well, it does bring a few questions up, obviously. We said, obviously, propellers is one thing. You talk about vibrations, and we talked about regulations and incentivization. You said the CapEx for all these solutions is like for the alternative solutions for fuel and everything is obviously expensive if you want to make some retrofits, change your propellers, have some more improved engines, use batteries and everything. What is done, or what do you suggest should be done to help improve? Obviously, CINDEX got some ideas of how to reward, incentivize. But at this stage, as you said, there's no real regulation that is giving you like taxation if you don't respect these rules, but there's no incentivization either.
Yeah, there are. There are two ports that are pioneers in the world, Prince Rupert and Vancouver in British Columbia. And they have...
It's quite far from here.
It's quite far, yeah, sure. But it's a good example because it has really triggered the interest and the momentum. They are rewarding today 75% of the port calls to ship owners that have quieting solutions or class notations. And that's quite a change. And we are working with several ports also discussing integrating underwater noise in their blue programs, green programs and whatsoever. And just to split the CapEx into the different stakeholders, because this is where we all have a different role to play. And it's clearly reflected in the IMO guidelines, which is not that usual to write down that not only ship owners and member states, but also class societies, banks, ports, designers, yards have to take their duties and work on. And this is written in the IMO guidelines.
But it's not compulsory yet.
It's not compulsory, and that's why we have progressed so fast at IMO, because if you discuss about noise for the sailors, for crew, it has been issued in 1984 at IMO, the noise code, and revised 32 years later. For underwater noise, it has taken hardly 9 years to revise and to have really prescriptive, not mandatory, but prescriptive in the sense of guidance, clear guidance to move on. And that's, to me, a nice proof that if we engage all stakeholders, then we move on together. And very important thing that was mentioned is the early stage consideration of this topic. Not only for new builds, but for any existing ship, to address it to the propeller designer, because propeller designers are experts for that. But as far as they have nothing in the specification, they do nothing for noise. And the computation capabilities have, it's a huge change that has occurred the last 10 years. They are computing now more than 200,000 geometries of propeller in a few days.
Great, thanks. Yes, please, because yeah, I have some additional questions for you.
I think that it is a very good opportunity now because we are in a new area of decarbonization, and decarbonization will allow us also to retrofit with high expenses and an important cost. So we can also include the other aspects into the decarbonization retrofit and into the new vessels, new builds. I think really we have a good opportunity now in this period.
Thank you. I have a question then for those of you who are developing new boats. Are there new solutions, new R&D solutions in a way that you're willing to experiment, or you're thinking about experimenting to reduce noise pollution from the ERDEV? I mean, obviously there's a new energy observer that's going to be launched. Ponant is obviously at the forefront of it. Are there, do you know, or anybody in the audience has got a new solution to reduce vibration, to reduce noise pollution?
We can give one example. I think most of us, when we are now flying, because we are still flying on planes, we have a noise cancellation on our ears, and basically there is several yacht builders that have tested some noise cancellation inside the engine room, and that's working quite well. It's quite still expensive and working on some university, and that's one of the topics we will cover on Energy Observer 3. And for sure, it's like the efficiency on boat. The best energy is the one that you do not consume. For the noise is the same. The best noise cancellation is not creating noise. So every vibration coming from something which is turning, we are trying to avoid, and working on optimizing the energy from the heat and the powertrain, drivetrain, and the hotel load. Having all that together, not having several channels, is also a way to optimize the efficiency, but also to be able to be stronger in the noise reduction by having some noise, let's say, vibration cancellation inside the boat.
Yes, you've got.
Yeah, we have two different projects. The main one is to come back to the wind, to use mostly the wind as a source of energy. As we saw this morning, the Wind Hunter, we have a similar project with the Far Wind and a couple of boats. A Far Wind just to produce hydrogen, and another vessel using this, or a fleet of vessels, zero emission, using this hydrogen for navigation, because for the commercial aspect, we need also to have stored energy on board for the hotel load and for the safety also for the passengers. So we are now designing this new generation of vessels with really the wind as the most important source of energy.
Thank you. I always say, let's go sailing. We know that's the solution ultimately, but obviously there's more and more, even in yachting we can see the combination of wind with other solution is is really gaining traction, which is good. I have a tricky question, possibly for Nathalie, and then I'll leave it to the audience. What you mentioned about coastal pollution, right? Noise pollution. I remember the times of the COVID when we had dolphins coming into Saint Laurent, right? No noise, the dolphins come. Noise, they stay away. Technically speaking, the boats that are near the coast, I kind of laughed about it, but it's not a big commercial vessel, it's not the big cruise ships, although they do come close, but it's all the small motorboats, the tenders, all the ones that are using, obviously, regular engines. First questions, if all these tenders and all these C-class boats from the Energy Boat Challenge run on batteries only, would that help? If we had only batteries, obviously. Can you calculate or give us an idea of the range of impact that these small boats throughout the summer are doing to the coast?
Well, obviously that's a very technical question. So I'm not a bioacoustician or a technician, but yeah. Obviously, yourself, you just mentioned that if the best thing to do is to try and adapt the tenders, etc., to not have internal combustion, etc. The boats, I mean, that boat over there that I can see through the window, it's not technically super close, but yeah, the effect, the body of water that's underneath is not that deep. We were talking about whales, but this is not going to be, again, I'm a little bit in the same position as Akash was before, a little bit of bearer of bad news, but there are new studies that have come out. Posidonia seagrass is affected by noise pollution. I keep mentioning this, and people wrongly say that Posidonia seagrass is just it's a invasive species. It's not. It's actually. I keep saying this many times. I said this to Thierry Voisin 10 days ago. It's number 2 on the list of strategic things from the French government. Why? Because Posidonia seagrass dictates your coastline. If the Posidonia seagrass goes, your economic zone is shifted. And as I've said before, we're all friends between France, Italy, and Monaco. But if that were to change, or if you're in a different area of the world where you've got gas fields that are just outside, all of a sudden these gas fields might not be yours anymore. So we're talking about butterfly effect, little things that have huge impacts that say, oh, well, it's fine, it's just a little grass. And you're absolutely right, that the approach has to be holistic. It has to be the big yachts. Now, funnily enough, the effects of Posidonia from the big yachts we can quantify now because of the smells, because of all that. But I mean, I've witnessed it. I live in Jean-les-Pins, and I've seen more and more, as we've seen, you can rent these day boats. You can have no idea about boating at all. You can rent the boats, and I've seen them rip up the. You rip up the anchor at the end of the day, and it's tufts and tufts of seagrass. So you're absolutely right. The approach has to be holistic to incorporate small boats and the big boats. But again, it's butterfly effect. All these little things amount to. We're talking about noise. It's not just the sort of whales losing their way. It's also reproductive things as well. They can't hear themselves down there, and so they can't find mates. They fight. I mean, it's. I know it's a little bit funny, but we heard that at the whale. We were on the same panel at the CMA CGM, and somebody from the Belgian government was presenting that, and it's exactly true. So we have the potential to make a difference, but holistically, you're right.
Thank you. Yeah.
Now, just maybe to give you an idea, because we are all noise expert inside the water, but I think most of us, we try sometime to have a sleep and to fall asleep, and we have a mosquito going to us, and it's quite difficult to fall asleep. Basically, the small boat is a bit the same. Small propeller, high RPM, frequency high, noise very like a mosquito. And we have a big boat, is a bit like, not a bee, but a bourdon, I don't know the translation, like a bit more warm, and you can hear from further distance, but maybe you can fall asleep easier. So it gives you some idea about, okay, what we are doing inside the ocean for the biodiversity, and that's why we have to try to optimize the frequency. But most of the noise is mainly coming from the propeller, from the measure we have done on Energy Observer. And that's something very easy to move and change for boats, because by changing the frequency, the shape, and the angle of the propeller, we can also try to optimize the efficiency of boat and to reduce dramatically the noise and the impact on the biodiversity.
Thank you. And when it comes to the rewards, what you said about the ports, I guess the ports within the C index is going to be taking on board this kind of incentivization program to support noise reduction.
This is what we're going to try and do. We've done it for CO2. But again, I think there's a lot of macro things that can be adapted to what I call our micro sector, which is yachting. A couple of years ago at the Grimaldi Forum, I was very inspired by a woman who's representing France, the French delegation for undersea mining. And what she said struck a chord with me, and I think we can all maybe take a leaf, when she was saying that, okay, incentivize is one thing, but to make it politically difficult for people not to go in the right direction also has an effect. By that I mean, for the undersea mining, what they do is that the countries that don't want to sign it, okay, but why don't you want to sign it? They have to motivate why they don't want to do it. And I think that that sort of approach can also be, it's like, you're free to do what you want, but why? Why is it that you're doing it? But we've chosen another thing, is to really incentivize so that the destinations can prove that they're also doing, so that our network of ports, which is growing, we've got some more announcements to make. The region of Sud France has actually incorporated the C index in its development plan, but it's a way for these destinations and these ports and these marinas to show that they're actively doing something as well. So, voilà.
Thank you. Time for a couple of questions. You've obviously had your coffee break already shortened by 15 minutes at least. So there's only time for 1 or 2 questions, if you do want to have a couple of questions. And then we'll take a short break. I think everyone needs a bit of fresh air, and because it's going to be pretty intense again after the break. Very quick question.
Yeah.
Yes.
Hi, I'm Neil Angley from the European Space Agency. Very quick one. We see that normally the decarbonization measures go hand in hand with reduction of noise reduction. What about air lubrication? Is it good, bad, not important?
When you say air lubrication, is injecting air inside the hull to try to reduce the drag. Yes and no. It's not a huge impact because those bubbles do not have a huge amount of energy, so the noise does not go very far. But it's some noise for sure on top of the standard noise on the boat.
Thank you.
So there are, in theory, a very good solution because it reduces drag, and for the same speed you have less energy, so less noise and vibrations. An adaptation of this, which is called a masker system, but not placed as air lubrication system at the forefront of the ship, but around the machinery compartment has been tested. And we obtain up to 20 decibel of reduction in that frequency bandwidth of the machinery. So it's very efficient. It's done by a Marine Institute in Netherlands within the Saturn project. So you can have all these figures publicly available.
Thank you. Another quick question? Very quick.
Yes, hello. This is Mazen Veter from Qatar University. The adoption now of hydrofoils that needs high-speed planing speeds, which will, of course, incorporate high propeller noises. What is your vision for such adoption, as it is now commonly and pushed by the technology to be used especially for transport of people like this? My question is, what do you think about this approach?
I can take it because I used to be an expert in foil, Alex.
Maybe you want to answer?
Yeah, no, it is true that basically, foil technology is something very good because you can reduce dramatically the drag as long as you are able to fly on the water. But to reach that point, you need to reach a certain amount of speed. That speed is depending on the weight and it's depending on the length of your boat, because just having an Archimedean boat, that's most of the time the most ecological way to carry weight on Earth. You know, we are pushing a lot on the yacht and the merchant ship, but that's today behind the train, the second best way or the most efficient way to carry goods around the world. So if you want to fly, for sure you need to go faster, and you can reduce by 2 or by 3 the consumption. Then you have, because you will go faster, you have the frequency which will increase. And for sure, that it's like the mosquito I explained a bit earlier. It's very noisy and aggressive noise. But the impact is also depending on the amplitude. So I don't know, you can have a very high, low frequency, but just having 100, 200, 500 meters noise pollution compared to a very slow boat that can have maybe 10 or 20 kilometers noise pollution. And everything is about compromise. And for sure, as long as you want to go on foil, I do not think you are considering trying to reduce the noise, but you are mainly considering to try to move fast by reducing the consumption. And it's always a question of compromise in between what you are looking for. I don't know if you have another...
No, the compromise is the right word. And also, maybe new materials can be considered to afford unusual geometries that you have with brass or metal propellers, such as composite propeller or additive welding and hollow blades. And this is a game changer. Then you can have totally new geometries that will solve or at least be considered under that dual constraint of efficiency and noise. And that's our constraint in the underwater noise. We are not emitting more CO2.
Thank you, ladies and gentlemen. If you'd like to stand for the photo and be given a round of applause before we go coffee or sailing. We're going to have a keynote about investing in the future of yachting, financing innovation and decarbonization. It's a keynote presented by Vivian Delaunay, who's the Executive Director of UBS Monaco. If you would like to please welcome in to the stage, Mr. Vivian Delaunay.
Thank you. I'm sorry that I'm the one who have to cut the coffee break, so don't take it personal. It's not my decision. Okay, good morning. And thank you. It's a pleasure to have the opportunity to speak to you today. As someone who advises a client on managing and preserving their wealth across generations, I've learned that not only effective capital just grow, but it evolves, protect, and position itself for the future. And it's a long-term advantage. So today I want to talk about why decarbonization of sea transportation is not only critical for health of our ocean, but also a compelling business case for us at UBS. One that impacts owners, builders, bankers, and everyone in the yachting ecosystem where you are all part of it. So this is just not a keynote about environmental awareness, but it's about foresight, value, and the future of your industry, and the role of capital that I'm representing it in shaping it. I mean, we all know that the ocean sustain all, produce half the oxygen we breathe, regulate global climate, and support more than 3 billion people. Warming water, pollution, and biodiversity loss are accelerating, and increasingly climate change is no longer a distant challenge, it's here. Protecting our ocean health is not optional, it's essential, not just for the planet, but also for prosperity. We're not here to do the UNOC again, or the Blue Economic Forum of Monaco, but it's good to remind it. We're seeing it impact directly. We see more frequent storms, disrupted seasons, shifting sailing patterns, and boating is already changing. And I think after several conversations with yacht owner, professional like you, one truth has become clear. If there is nothing left to see above the sea and below the water, owning a yacht will lose its meaning. And at UBS, we are committing into mobilizing capital, knowledge, and collaboration to protect life in and around the ocean. And since yachting has always been a symbol of luxury, innovation, and exploration, it has the opportunity and the responsibility to become a symbol of sustainability as well. But for us, there is another reason to act. Because for owners, builders, and financiers alike, the decision we make today will determine who thrives and who is risking of falling behind. in a market that is being reshaped by regulation, reputation, and rising expectation. So let's start with the facts. I mean, you know more than me, but for example, a large diesel-powered super yacht can emit more than 7,000 tons of CO2 per year. That's more than most of the commercial ships and more than the lifetime footprint of many of us. But the carbon footprint goes far beyond the engine. It's in the whole construction, the material, the system on board, and the operation. And while super yacht or yachting may be a small fraction of global maritime emission, its symbolic weight makes it highly visible and increasingly exposed to scrutiny from regulator, investor, and the public opinion. So this is not just an environmental problem. For us, we really see that as a strategic risk also for our clients. It's an asset risk. Will the vessel we finance retain its value in a market that is going through decarbonization? It's a reputational risk for our clients. What does ownership signal to stakeholder and the next generation? It's an access risk. I mean, we see it. Will my yacht be allowed to enter key port, conservation zone, or charter under evolving regimes? And it's also obviously a regulatory risk. Commercial shipping is already covered by the Poseidon principle that are pretty restrictive for financial institutions, and there is a growing pressure to extend those standards to leisure vessels. And that's a lot of risk. And that's where the banker side of me, and sorry, I'm the banker in the room, makes a comeback. If we are financing this asset, we have to ask ourselves, how do we protect them? How do we adapt? How do we lead this evolution, not just to react to it? So let's turn what it makes sense to have UBS and Monaco here together. I mean, the Principality has committed to carbon neutrality by 2050, and it has launched several initiatives to reduce the environmental impact of luxury yachting. I mean, there is a consistent support from the foundation and a Series 9S Prince Albert II, which has championed ocean protection for years. The Yacht Club de Monaco here is a good example of that, and we are a partner with them. They have introduced a green hydrogen ponton, and I mean, the Monaco Energy Boat Challenge speaks for itself. At UBS, we are proud to be part of this momentum. For over 3 years now, through the UBS Foundation, we have partnered with the Prince Albert II Foundation and others to support the conservation of the Pelagos Sanctuary in the Mediterranean Sea. And we have renewed this partnership just during UNOC to make it even bigger and stronger. And we are also supporting similar initiatives through the Blue Marine Foundation in Greece and Italy, preserving biodiversity in building a resilient blue economy. We are also a founding member of the Sea Index through Credit Suisse, which used to be a brand and now a brand of UBS. And this is really something that has a meaning for us. And there is a real potential here, not just to do good, but to do well by doing things well. And you can ask yourself, okay, that's old word, but why does it matter to our clients? Buyers, which are our clients of super yacht, especially younger generation, are showing a growing interest in low-emission vessels, smart onboard technology, and clean operation. Not out of ideology, but because they understand that this asset must be future-proof. We hear the same question more and more from our clients. What happens if the regulation change and start targeting super yacht? How does this super yacht fit into my sustainable asset portfolio? What will this vessel say about me, my value, my position? And it's not just a super yacht question, that's an investment question. And they are shaping the future of your business, the super yacht business. And so what is the role of wealth as a strategy? What we see is that owner and investor are not just consumer in that pace. They are market makers. Their choice influence the direction of shipyards, the structure of financing, the development of marinas, and the evolution of charter market. In a world where public policy on sustainability may fluctuate, the true driver of change will come from strategic, long-term thinkers, people with a vision, capital, and influence. If you choose to own or finance a next-generation super yacht today, you're not making just an investment, you are making a moral gesture. You are hedging against risk, aligning with future regulation, and building reputational equity that strengthen both brand and asset value. So where is the opportunity and how you as innovators and entrepreneurs fit in? I mean, I was amazed by the conversation just before on the noise and how do we conduct noise control for super yacht. But let me briefly highlight the 7 drivers that we see at UBS being key when we look at the risk. Obviously, material and construction, I'm not coming back on that. We see propulsion innovation, sorry for my English. We see alternative fuels also. I mean, this was discussed also. We see onboard renewables, I mean, solar panels, wind assist system, battery storage, that was discussed also. We see artificial intelligence and data optimization. How do you optimize the route, the smart management system, the routing, the engine performance? How do you increase operational behavior with eco-speed cruising, also itineraries and clean hull protocols? And the last point is about us, is about finance and banking. European banks and insurers are trying to put in the lending terms a lot of the ESG criteria. And when it comes to yachting, it's all tailor-made, and that's very important. So at UBS, we see ourselves not just as philanthrope and partnering with foundation and the Yacht Club, but we see ourselves as financier, banker, and people that are deploying capital. The first thing that is very striking is that beyond the foundation, we are conducting a program which is called the Global Visionary Program. And we have supported companies like Daphne Technology, which are developing advanced systems to reduce emission from vessels. And every year, we are stepping in with several entrepreneurs in different fields, all targeting decarbonization. And we're happy to do so also in a super yacht system. So if you have great idea, and I see a lot of great idea around the room, and you want us to invest, please do not hesitate to reach out to us. Second, by creating tools. I mean, we have been partnering on creating the Sea Index tool. It was in 2020, and this is used across the super yacht community. And the third, of course, by unlocking investment in the blue economy. Ocean have been underfunded, but regulatory shifts are opening new opportunity. And through dedicated strategy, we help our client to deploy capital in what we call the blue economy. We just launched last year an investment fund for our clients with more than $250 million to be deployed in investment company. So here is the message I want to leave you with, and not as an environmentalist, but as a strategist of wealth. The decarbonization we're seeing in yachting is not a trend. We all know it's a transition. And it's being driven by regulation, capital market, risk exposure, and changing client value. If today you are building, financing, and operating a yacht, you are making a long-term bet on the future of luxury. Those who invest in innovation and efficiency are not compromising on experience. They are enhancing value, protecting reputation, and building resilience. And this is what leadership looks like: forward-thinking, commercially grounded, and impact-driven. And at UBS, we do not want just to follow this transition. We are part of it, but we want to lead it. So please help us and reach out to us. Thank you.
Thank you. Thank you, Vivian. It's interesting what you said, because it kept reminding me about Jeff Bezos' wedding in Venice, for whatever reason. But you can see what we say about the image impact that it has, even if he has actually a sailing yacht in principle. Many thanks again. Let's carry on with basically efficiency at sea, which was mentioned as well by Vivian. Cutting costs and emissions through technology. We have quite a wide panel to join me on stage. And so I'd like to call Ricardo Repetto, who's a global vessel type responsible yacht sales specialist at ABB, Marine and Ports. Matt Venner, who's a senior naval architect at Lateral Naval Architects. Alexandre Kayser, who's the CEO of Sirocco. Arthur Bohr, who's the site and key account director at Monaco Marine. And Jean-Jacques Boud, who's the head of yacht management at V-Ships. So 5 of you, which means a number of people to talk, which means you don't have more time than the others, so which means that you have to be efficient, which is a good thing since the topic of this panel session is efficiency. Thank you for joining me on stage, and let's start with Ricardo.
Hello, ciao to everybody. I'm Ricardo, ABB, and I really like this panel and the title of this panel, efficiency, because we heard that the solutions are there, and we need just to be more efficient to make the last gap. And we strongly believe in high efficiency. And we know that, try to imagine, for instance, your perfect yacht, your perfect boat, independent from the kind of boat we are talking about. And now, when you have your ideal electrical or propulsion platform on board, try to think, I want something more. I want to remove an alternator. I want more silent because I want less underwater radiated noise, but I want also more comfort on board. What to do? So ABB did this. We copied. What we did, we tried to copy how the animals are swimming in the sea. A sperm whale has an efficiency in the water of close to 90%. So we try to imitate the movement of the tail of the fish. And this is, the theory was there, 10 years that is there, but was not available, the technology. But with the today technology, we can have a cycloidal propeller with the blades that are following a trochoidal trajectory. That is the challenge. How to do it? With every blade, it's controlled by an electric motor that is individual controlled. So we have the freedom now to move the fin as really we want. So now it's became software, no more technical. And now we have the software to do it. Recently, we had done the open water tank test in Marine, that they demonstrate amazing value, more than 80%, 0.81 in open water efficiency. Consider that an optimized propeller in an azipod, in a yacht where we have to take care about the comfort, so we have to play with the pressure pulse. It's difficult to reach 53, 54%, and now we have a leap. And this leap of power requirements permit us to be more flexible in the design, and also to have less impact with the mission as direct consequence. But again, I think that the strong research of the high efficiency, so we have to think different. We cannot do as we did in the last 100 years. With the screw propeller, we have to think something different, even how to move the boat, not only how to utilize the power produced on board.
Thank you. Thanks a lot. I think there will be plenty of practical and technical questions, but the good thing is that next to you, we got lateral naval architects with Matt, who's going to probably be intrigued and interested in applying these into his yacht.
Yeah, absolutely. Hi everyone, I'm Matt Venner. I'm a senior naval architect at Lateral Naval Architects. So just briefly about Lateral, we're a company of about 50 multidisciplinary engineers, all specializing in the superyacht industry. We work on all projects of different shapes and sizes all throughout the world, from 20 meters all the way up to 100 plus. We offer concept design solutions through detailed engineering all the way to delivery and refit. Our core focus is definitely engineering at our company, but one of the unique things that we do is innovation and focus on looking at solutions for tomorrow's yachts as well as today's, which brings me on to my next slide. We thought we'd select 4 things that we're looking at the moment that we can delve into more if we have the time. So we're looking at the moment, gathering data from AIS, so looking at the actual global fleet, how are they really operating compared to perhaps how they're designed. We've got a product we're calling the Energy Audit Study, which is looking at current yachts that might be interested in getting a refit. we're going to be looking at how that yacht's actually operated, and we can suggest, is there something that you can do, be it large or small, that will help you operate your boat more efficiently. We've got our energy transition platform, which is about delivering tomorrow's yacht today. Eagle-eyed viewers might see that that's got the ABB Dynafoil actually installed on the back, so thanks for that, Ricardo. And then computational fluid dynamics is something that probably gets a lot of naval architects excited. It's optimization through use of computers, looking at getting the best kind of underwater hull form, reducing the resistance as much as possible, which should reduce the power on board and might reduce the emissions.
Thank you. I'm sure there'll be plenty of questions for the actual solutions that you're putting forward. Alexandre?
Thank you. My name is Alex Kezerg. I'm the proud CEO of a company called Sirocco, set it up in 2019 in Marseille, 40 people today. Maybe you can switch to the other one. Today we are providing to masters and navigation officers on board new kind of voyage optimization platform. It's a SaaS platform, web app, very easy to use, but computing a huge calculation to provide to the crew only the best and most efficient route, taking into account, of course, the capabilities of the ship, the operational constraint of the crew on board, and at the end, providing followable recommendation to the crew, fuel saving at the end, I mean energy saving. Today we have 120 ships equipped with the solution, fleet deployment on every kind of, let's say, conventional merchant ship, tankers, ro-ro cargo ship, some cruise ships as well. Yeah, maybe we can switch to the other one. What the core of our platform is a digital twin platform. We are making a very accurate digital twin of the behavior of the ship. Of course, we take into consideration all the naval architecture data, and we merged it with the operational historical data we are able to gather to have the best overview of the capability of the ship and to provide very accurate recommendation with very accurate weather forecast as well. But at the end, providing fuel saving to the clients.
Thank you. Just before we get to Arthur, 10%?
Yeah, it's the average annual fuel saving, energy saving we saw on the majority of our clients. Of course, it's if you take we have different mode of operational mode, but if you choose JITA, so it's just-in-time arrival, when you have an ETA, the average fuel saving is 10% on an annual basis. But of course, it depends on the weather as well. So it's between 5 and 25% on each voyage.
Okay, so we'll have to see what other solutions can help bring it higher, this 10%. Thanks, Arthur.
Morning, everyone. So I'm Arthur Boer, Director of Monaco Marine here in Monaco. We're a refit network of shipyards specialized in refitting boats from 20 meters to 100 meters plus. As a refit shipyards, we don't really go into the design of the boats, what my colleague were talking about, but we take care of the boat once it's done. A yacht is an energetical system where lots of energy is produced and a big part of it is lost. So the first step is actually to analyze, and the proper way to do it is to audit the boat and know the boat. Pretty much every boat is different, so it's a case-by-case scenario. So auditing is one of the key. The really good news is that we have hundreds of solutions to put on board. There's not one perfect solution. There is best solutions by boat. So we need to know this before putting it into it. Then there is two main considerations to have, which is what produce energy, so mainly the generators, And we can clearly see that we're losing lots of energy on this part, so that's a main concern we can have. There is solutions existing, there is really great solutions arriving on the market. And then the second part, we talk a lot about propulsion, but the main concern is actually the hotel load, which is up to 70% of the energy used on board. And there is hundreds of appendix where we can work on. From the study we made, we realized that most of the energy used by the HVAC, and we are today able to give proper ROI to clients to show them that it's worth the money doing it, and in a pretty short amount of time.
Thank you. And let's conclude with Jean-Jacques.
Hi, everyone. So I'm Jean-Jacques. I'm the head of yacht management at V-Ships. So we like to say we are a boutique yacht management within a large global reach company. So the yachts, we focus on the largest segment of yachting, probably 80 meter plus. Interestingly, at V-Ships, obviously, for commercial consideration, decarbonization and cost saving has been like a main topic for our clients. So we have an entity called VRD, which is fully owned, which has been working on these topics for many, many years. And we are looking obviously how to use or cross-sell these systems to the yachting industry. So for us, the main topic at the moment, as Sirocco is doing, we are working a lot on AI-powered ship routing and yacht routing, dynamic mapping of sea conditions. Also, we are involved with AI-powered crew monitoring. Let's say how they behave with regards to sustainability. Very interesting project is a fuel-powered tenderboat, which could use as a microgrid connection to the motorboat to fill hydrogen to the motherboat. So, yeah.
Thank you. Plenty of questions. I've got plenty of questions. The first one is one of the things that all of you mentioned was data. And something that was mentioned before was, having this baseline information index and what you said about hotel load being 70% and all that. So how strong is data collection nowadays in the yachting side? Small yachts, big yachts, data collection to be able to get that benchmark, that baseline. And obviously we can go back to the C index about that. But and how proactive are yacht owners into having that data made available in order to then work on improving? Who wants to answer?
I have some comment about it, because as ABB, when we design or we develop a propulsion platform together with the shipyard and together with the client, all our components, they have the possibility to talk each other. So we invented this fantastic things which is called RDS, which is always embedded in our system and which is able to collect the information from the component on board that they built up the propulsion power plant. And this permit to us, in case of service, for instance, in case of unexpected failure, to remote connect. And I always found a great resistance from the owner teams, that they are really scared on the possibility that someone connect on board. ABB is put high attention on the cybersecurity, so we cannot really connect if they don't open the door. So usually it works in a different way. But the fear that they have make I think a quite big obstacle, because I think that a system like this, and we are not the only one to have this possibility nowadays, permit the shipyard, for instance, to collect information to build better the next hull platform. So one thing that I always thought, why, as we do for our system, the shipyard, now a question to the shipyards, why you are not installing scientifically the sensor that permit you to measure the performance of the boat, also for the efficiency point of view, and collect the data. I know that maybe owner doesn't want to share, but so if you start from the beginning, it's a cultural matter, I think. I think that could make, just I put an idea on the table.
Thank you. Very good one, as we also deal with cybersecurity in the following panels. So.
Yeah, I totally agree with that. I think as a naval architecture firm who's maybe once removed from the owner, perhaps we really struggle to harvest this real world data. So the tool that we've developed is just in-house, looking at the freely available data online on, you know, marine traffic, or other AIS websites are available. And I think being able to have that data actually given to us would be so much more useful to know how are these yachts being operated in reality, compared to sometimes how they're designed, which is a 1% operation of the year, or maybe only ever on sea trials. This yacht will never actually do that speed. So yeah, access to that, we see major barriers, but it would certainly help if those were lowered.
It's actually a starting point.
Exactly.
Well, I totally agree with both of you. We're just at the start of this, and we need data to do properly our job. I think as soon as we will make owners understand that the benefit of the data is way above the risk, we will gain a part of the war, and so we would be able to do it. And one really interesting thing, we've seen a boat recently who put actually capture on board, and just by the change of behavior of the crew, we've seen a dramatical change in terms of consumption. So just by this, we clearly see that there's a systemic to be worked on board, but there's the behavioral is a huge impact as well.
Jean-Jacques, you must have data as a yacht manager.
Yeah,
right?
I was about to say, I think the data is available. I mean, there are so many ways of acquiring data with smart, smart acquisition and everything. I think the challenge probably now is how to aggregate this information and to use it. So, which means probably to find a protocol so that it's unified and that we can, everyone can use whatever it needs for its application. So I think what we need now is a collaboration, because I see we are a lot working on the same topics actually, and probably losing time and resources. So probably, yeah, future is a unification.
Alexandre?
Yeah, that's funny because a lot of our clients, they have access to the data, but they have access if they pay a subscription to either the shipyard or the engine providers, or so. And often they don't even take the subscription because they cannot use it. So sometimes it happens in the past that we had to pay the subscription to get the data from our client. That's funny, but at least you train your models with accurate data of ships you equip. So it's, for us, it's improving our processes, but it should be either free or mandatory for a ship owner to buy his data, or the shipyard to make it free for the customer. So for sure, data is the key. Our team of data scientists and gets bigger and bigger, and that's the way for the future.
One of the things you mentioned, Alexandre, is about the fact that obviously you do it on shipping, right?
Which is a little bit different compared to the yachting.
And that's my next question is what you've developed and what you're using, and okay, it works fine, and shipping has got regulations that actually now they have to submit information, right? They collect and submit data. How do you see that being possible in the yachting side, where in fact the freedom of movement of a yacht means that determining the best routes makes it a lot more complex than for shipping?
With our platform, we are strong in deep sea routing. So that means from pilot point to pilot point, like trans-oceanic, trans-Pacific. Coastal routing, we're not that good. And for sure, the yachting industry doesn't work as a merchant ship sailing at sea. So there are for sure ways to better that efficiency. Our platform could benefit to like large yachts, but then you build one twin for one yacht is not that efficient, commercially speaking, as well.
What Arthur mentioned was about crew, right? Making changes, and so obviously having that connection with the crew and captain to be able to supply the data, I would say almost to the point that the owner doesn't even need to know about it. Isn't that something that could be also a way forward? I mean, getting more and more crew and captains involved in the process of improving?
Yeah, I think absolutely. We've heard of one yacht recently where the crew have all bought into kind of almost like a scoring system, and they've got a monitor on board that says how much energy they've saved throughout the day. And it's an attitude shift as well. The crew are all trying to make their yacht the most efficient it can be and operate it sort of almost perfectly. And apparently the savings that they've got is kind of 20-30% at crew-only operation, which is massive. You know, we're chasing 1% on hull design if we can. 20-30% on hotel load, you can start to reduce all your generators, you can reduce your technical space sizes. It's really impressive. So the attitude is also something that needs to be addressed, I think.
What you said about the fact that they had like a form or basically filling in the data and being able to track the data.
Yeah, it's like a competition.
Yeah. Isn't that something that we could actually have on all yachts where the data is being tracked and it's compulsory to have that data displayed, and then it can become a competition?
Yeah, I think, you know, the crew in the harbour talking to each other on a night out, like, oh, how are you guys doing compared to how we're doing? Something like that might, you know, lots of people are competitive, aren't they? So that could work.
This is a process that we saw in commercial, in the cruise segment. The cruise operator, they are already doing this kind of comparison. So same vessel, why they are performing differences, matter-related operation. In the yacht, I see that this is a big challenge. First, because we have to remember that a yacht, even if it's a ship, is more, how to say, a private villa that is floating in the sea. And the crew, the captain, they have a lot of things to do also for a bureaucratical point of view. And usually the structure of the yacht company, of the crew, is not like a commercial vessel. So they have less figure involved. So the captain has to do a lot of things. And probably this one, if it's not really mandatory, in the list of priority, unluckily it's really low. So we should think something more easy, more automatic, more that require more human being to do it, because the crew on board has already a lot of things to do, and I'm afraid that that is the dream, but the competition between crew on the efficiency on a yacht probably is still far if we want to be realistic. So let's focus on pragmatically, on really what we can do more than what the other they have to.
Well, you said the word mandatory. I think in the future it's going to become mandatory.
Exactly.
When you're a yacht owner and you own a company and your figure is attached to the yacht, it's going to become one of the most important things. So yes, it will, from my point of view, and clearly the crew is maybe the most important on board. For the experience of the yacht owner, but as well for all the operation. So yes, we need clearly to push, and they need to push on that direction.
Yeah, I fully agree. Crew behavior is a key anyway, especially in yachting. And talking about this index performance and everything. So at the yachts, we work with a startup called ETYC. I think Claire, their CEO, was there. And that's something we will enforce in our fleet. This is like a software which monitors, gives targets to crew. So they train crew, they have KPIs, and they have to follow. So as a score system you mentioned, and with a certification at the end. And yeah, at the yachts, we enforce that.
Okay, so obviously the human factor is essential, but you also mentioned the fact that AI is becoming an important aspect, and how can or how does already AI help in gathering, analyzing data and making improvements, or not yet?
I think, yeah, we're making use of AI very lightly at the moment. our tool that we've got that scrapes the data off the internet for the AIS positioning is based on an AI tool, and then it sort of populates the data sheets, and we're making our Excels more clever using AI. But for me, it's still in the early stages. Definitely at a naval architecture level, anyway, you need that human touch and the experience that I'm not sure if AI databases can give you yet. Speaking from a man who maybe one day AI might have a naval architect's job, but hopefully not soon.
Well, I think AI is everywhere, but I'll go at the opposite of your question. We're looking into the future with AI and really modern and advanced technology. But a yacht is quite a basic in terms of technology and construction. And we always think that we can be innovative. But actually, all the technology we need, they already exist, and they exist in way bigger industries that implemented them a long time ago. So in construction, in hotels, and we do not have to reinvent the wheel. A boat is a really particular system, so clearly taking some risk and having an owner ready to take some risk on implementing something that has never been tested is a real problem. So we need to prove to the owner that it actually works in any way possible to then implement it into the boat. We do not have huge research and development sector compared to other, let's say, proper industry that we can work with. And we need to be inspired by the other, not really to lead in some ways.
Yeah, AI, we use it in our algorithm for routing. So at the end, of course, it's a better way to propose options, but at the end, it's still the masters and the captain who take the decision. And if they don't trust the solution, they are not obliged to follow. So you have to convince it. You have to use AI to provide scenarios, and at the end, it's the human who take the decision. Same thing with the supports of. We have a team of real people that are helping crew at sea 24/7, and they give advice according to the weather the ship will face, and we use AI to analyze, or let's say pre-analyze the weather they will be facing with some basic recommendations. So it helps our team to propose options. So it's like human enhanced, either than replacing human by AI.
One of the things that was mentioned a few times, and even on the financial side, is that all the solutions, okay, fine, technically they exist, technologically we know they exist and everything. The implementation cost is always hefty. Whether we're talking about new propulsion or alternative propulsion technologies and fuels, whether you're talking about new systems for noise reduction, whatever, there's always an extra investment to make into adopting solutions that are there for improving and reducing, obviously, or decarbonizing. How do you, from your experience, since we have the wide range of experiences here, what's the scale between that level of investment or extra investment and what I would call the amortization timeline? That can be something that can be helpful for our banker friend here to understand from practical experience.
In my experience, it's hard, this one, because return investment of the yacht for a solution which moved the boat and they use the power produced on board is directly dependent from the operational profile of the yacht. And every yacht has its own operational profile. We know that the industry is working to find a way to measure this operational profile for yachts. Is done on statistic base, but it's difficult because every yacht is used differently. Often the yacht are using only in the best possible condition, because if conditions are bad, maybe the owner doesn't want or doesn't use the boat. And the return on the investment became so long. For a solution like our latest, the Dynafin, what could be a return on investment for a ferries could be a few months. In a yacht could be some years. Or depends how you use the yacht. Could be more than the ferry if you use the yacht more than a ferry, but I don't think so. And so the solution is there. How you use it make the difference.
Jean-Jacques?
Me, I think it starts, instead of reacting, that we are doing now, we start a little bit planning. I take the example, so I'm an auditor for French government on maritime affairs. When we do, let's say, meetings or plans, it's over the next 30 years, you know. So let's say, what will happen in 30 years? So you have to really to think outside of the box. Even if the technology is not existing, you know, sometimes can be a bit crazy or seem impossible, but with everyone around the table. So I think that's how you can amortize, where you have all the players, engine maker, builders, operators, shipyards, and really plan ahead.
Thank you. Actually, I would like to jump back on what you said, Ricardo, is the fact that since you don't know what it's going to be, the operating profile, to me is like, well, then all the positive solutions that can be implemented should be implemented, because at the end of the day, it doesn't matter. It will just have a positive impact, and there's no return on investment expected.
This is why I love the yacht segment.
Thank you, gentlemen. Questions from the audience? Plenty? Practical, technical? None? Everyone is starving? Well, we still have 2 panel sessions to come along. Well, thank you very much, and please, if you can sit. Yes, you need to stand up for the photo. Thank you, gentlemen. So our next keynote, a brief keynote, but will be a very interesting one from Neil Angley, who's a BAS Maritime Lead at European Space Agency. Please welcome him with a round of applause. The floor is yours. Well, you can, yeah, whichever mic. Should be all right. Test.
Hello.
Perfect.
Hi. I'm probably the odd one out in this room, as I don't come from the maritime sector, but hopefully I'm going to be able to provide some interesting information for you. You might have heard about the European Space Agency through the exploration programs, the satellites, launchers, Mars and the Moon, and we do all that. But we do more than that. We also deal about the data that we are generating on those satellites to be used on Earth. And we've been doing that on the ocean sector for many decades, measuring the sea temperature, salinity, sea levels, etc., etc. But the program that I'm representing today is not about ocean science or pure R&D, but it is about supporting commercial industry to leverage this wealth of data that we can acquire with satellites or on ships, and then transmit that data to shore, as we were just hearing on the previous panel, having this transfer of data with the use of satellites. The space sector and the maritime sector are closer than you think. And I'm not talking metaphorically, I'm talking physically, because when you are outside the EEZ, you're physically closer to the orbit of the International Space Station than you are to shore. That means that all the data that you're generating on the ship or on shore, that is going to be actionable information to help for the security, safety of the ship, to help with the performance, with the sustainability of the ship, is going to come through satellites. The program that I'm representing is the main goal is to provide funding opportunities for SMEs, startups, and large corporations that are developing commercial systems that embed space data or space technology at any point on the value chain. That could be satellite communications, AAS, Earth observation data, weather data, etc. And what we provide is zero equity funding, and you retain the IP. Typically, the equity funding comes between 50 and 80% of all the development costs. And the idea is to generate these commercial services that provide socio-economic return, that provide sustainability value and or safety and security value. We've been doing that for quite a long time now, and we've completed, in the maritime sector alone, over 100 projects, 16 of them currently running, and another 30 in preparation. And on what areas? They range widely. We are addressing topics on maritime safety and security, on maritime sustainability, ports, and the wider blue economy. Many of the topics that we've been hearing this morning on decarbonization, on the use of alternative fuels, on IUU fishing regulation, but as well on the safety part, protection of critical infrastructure, and the water fiber cables, URN, you name it. As long as it has some use of space data or space technology at some point in the value chain, that is something that we're interested in exploring with you. To go a little bit more with the topic of today, that is decarbonization, I just wanted to briefly mention this funding opportunity that we recently closed, that was running over the last year, that was addressing decarbonization. We did it with 4 different topics or verticals, because as it's been discussed this morning, we think that there is no silver bullet at the moment, and we looked at the decarbonization from different perspectives. One of them is the maritime decarbonization through the use of digital solutions and optimization. And in that one, we were looking at solutions such as just-in-time arrival, predictive maintenance, optimized routing planning, and so on. Just as an example of one of the projects that we are currently running together with Awake AI, ABB, and Wallenius Marine is quite a large project on route optimization, but end-to-end, including the port side and the port call, so having the just-in-time arrival solution. The next one that we looked at was focusing on the port side, and in here we were looking at improvements through the digitalization as well, but as well on cold ironing, automation in the port ecosystem, the monitoring of emissions, and other elements of the port. Next one was on autonomy. We know that the goal of autonomy is not the decarbonization per se, but it can have implications on the decarbonization. So we were looking at what impact can we get through autonomy on decarbonization. And I think I've lost my slides. Yeah. The last one or not? No, but if I click on the next one? No. Well,
there must be a slide missing.
Yeah, a couple of slides missing. No worries. I had some other examples of Grimaldi doing some autonomous docking project in the port of Livorno. And the message that I wanted to give you is that the European Space Agency is Eurospace Agency, is the space agency of all of us Europeans. Sorry if someone is not European here. And we are here to support you. And we have some specific calls, like the one that I mentioned on decarbonization. We have another one on underwater radiated noise that was the topic today as well. This one is going to be opening in September. Unfortunately, you don't have the link, but if you find me somewhere in LinkedIn, I'm happy to provide the links and so on. And last but not least, we have a permanently open call where industry can proactively propose new ideas. When you have innovation that requires some funding to close this gap of the chicken and an egg, to provide some scalability and to do pilots of the solutions, we are here to help. Please get in contact with me and we'll be happy to help. Thank you.
Thank you. Will you take some questions?
Sure.
Yeah, okay, so we've got a bit of time, a few minutes for a couple of questions. If you have some, or if you already have some projects that you'd like the European Space Agency to support you with. No questions. Okay, fine, great.
Free cash.
Well, thank you. I don't know if my photographer is around. Yes, he is, sorry. For the picture. Thank you. Thank you, Neil. So we did talk about AI briefly before. We did talk about cybersecurity briefly before. The next two sessions and last sessions for today are about the digital crossover, AI innovations, driving maritime and automotive transformation, which should certainly be of interest as we'll have a bit of views from the automotive sector. And then about cybersecurity in the maritime world, enhancing transparency and security in shipping and how that can apply to yachting as well. So for the first panel, I'd like to call Sergio Savaresi, professor at Politecnico di Milano, to come on stage. Siobhan Philippe Chan, who's the senior technology engineer of ABS, American Bureau of Shipping. Filippo Belsecchi, who's the engineering manager at Ferretti Group, and Kevin Duffy, who's going to join us online, I think, I hope, I'm not sure, because we haven't kept to the expected time, so we'll see whether Kevin manages to join us. Welcome, gentlemen. If you'd like to give them a round of applause, so that they don't feel prejudiced against the previous teams. So welcome. Let's start with Sergio. I don't know if you've got slides or not, but you can pick up a mic. So, all right.
Yeah, if you can. Okay, perfect. A couple of slides. I'm the other outlier of the group, I think, because I'm talking about what's going on in the automotive sector. A couple of very simple but important concepts. The mobility, the personal mobility based on cars will see in the next 20, 30 years a revolution, which is not much advertised by car makers, but is going to happen. And the revolution is the shift from personal ownership of the car to a servitization of the mobility, or mobility as a service. The key point that I would like to stress is that this revolution can happen only if the autonomous driving technology, which is AI applied to physical system, is going to be implemented. The motivation is very simple, because today car sharing, which is the simplest example of mobility as a service, does not work because you have to walk and find a car. So when you can get the car can come to you and become, for example, a robotaxi, the revolution can happen. So, second slide, please. This is what we expect in the future. 4 steps. First, a first wave of electrification. The first wave of electrification, we estimate, can only be no more than 15–20% of the personal owners of cars. The motivation is that personal cars have a very small mileage. In Italy, the mileage is about 8,000 kilometers per year, which is really small, very small for making electric car affordable and sustainable. Then we need the autonomous technology, which is the enabler of this revolution. With the autonomous, we can move to a mass market of servitization, and electrification is perfect for the mass market electrification. Be careful, from here to there will be a reduction of the number of cars of about 10 times. In Italy, 45 million cars, personal cars. We expect 5-6 million of cars is going to be enough. So it's a revolution enabled by the autonomous driving technology. I don't know if in the boats something similar can happen, but I think it's very interesting to see what's going on in the automotive market.
Thank you. Great introduction.
Hello. Hi, everybody. So yeah, I just want to kind of give a very brief, quick overview of where ABS are in relation to what we're doing within the market of AI, because we appreciate that it's not just kind of one lone function. So if we just start. So the scope of AI is ever-changing. We're continually talking about this interconnected vessel. Apologies for the design transitions, but we've kind of broken this down into 3 different quadrants. One being the applied research section, where we look at green ecosystems, materials, vessel performance, and blue economy. Just skip to the end of this one, and one more time. Yes, and then we've got our clean energy transition and digitization. All of these different kind of bodies of research are kind of culminating in one direction, and that is kind of looking at AI. But we're not kind of juvenile to think that AI doesn't come with a wide variety of challenges that kind of are unbeknownst to us in the maritime industry as we see it. If we just kind of establish and take a quick screenshot of various challenges that we can kind of look at, we can discuss. Things like cybersecurity, training and competencies, all lead on to bigger and better things that we kind of need to, you know, really hit the nail on the head and look towards developing good solutions for the future.
You don't want to comment on a bit more details?
I'd rather get to the questions and then we can talk about it in a bit more detail rather than hearing me talk about a PowerPoint.
Okay, take pictures because it's not going to come back. Oh, good. All right, Filippo.
All right, good morning, everybody. I'm Filippo Belcecchi. I'm the engineering manager for the super yacht division at Ferretti Group. I will not introduce the company because in this room I think is well known. We can move to the next slide, and just to give a couple of numbers. The next one, again. This is not mine, okay. But just to give a couple of numbers, the market for AI as of today is considered to be about 2 trillion. If we want to consider the economic value as an indicator of the value that there is inside this type of technology, we have already an indication. It is also growing because the pace is about 90% every year. And it is a technology that is touching all the industries. So the yachting industry is included, but also the social life, because I think everybody of us has in his pocket this device. And I think also that the previous panel has already introduced, and I'm happy to hear what they have said, the importance of data. And the effort that at Ferretti Group we are doing is to implement a system to collect the data from all the sensors that are on board. I've heard also something by Azimuth and in the same direction. Clearly, another industry like automotive is quite far ahead with respect to the yachting industry. And again, the first step is collecting data. Data then give you the opportunity to kick in with AI and improve efficiency. At Ferretti Group, we are doing, let's say, the effort in 2 directions. The first one is, let's say, acquiring the data from the product. We are very close to having the system that ABB was asking to have, so transferring directly from the boat to the cloud, and then being able to get information from the data directly from the boat in real time. And on the other hand, we are also tracking the processes with a digital platform where all the projects are managed, and also all the steps and let's say the interactions with the suppliers and partners is tracked in order to, let's say, understand where the value of the process is locked.
Thank you. Before we get to Kevin, when you say you're collecting the data, you're implementing the system for data collection on board the yacht and everything. So do you do that with the agreement of the owner, or you just do it as a shipyard taking the initiative of collecting data?
No, we went through a very complex process of, let's say, analysis from a legal perspective, not only from a technological perspective. We have all the paper basically ready to be submitted to the clients. We need we are very close to have an agreement with the partner. We have already made the pilot projects. The technology is working. In the end, we are not talking about rocket science. As one of the other panelists was saying, all the technology is there in other industries. It is already working very, very well. And it's more a cultural barrier because, again, all of us have a smartphone in their pocket and the data position is tracked already.
As long as it is safe and protected. But we'll come to that afterwards. Okay, thanks. Is Kevin with us or not?
Yeah, can you hear me?
Yes, we can hear you. We can't. Yes, we can even see you. Perfect.
Yeah, thank you.
Okay, so floor is yours.
Yeah, thank you. Good afternoon, everybody. Apologies, I can't be there in person. I got thwarted by the French air traffic control strike that happens today and tomorrow. I just thought I'd bring you some examples across Rolls-Royce of where we're using artificial intelligence and data. We're using it in lots of different areas, not only in customer applications, but even in our own applications. So I just thought it might be useful to bring some examples that maybe we can talk about later. The first one on my slide is where we're looking at service reports and service tickets that come through from customer engines. And we're looking for evidence of cybersecurity attacks. And it allows us to sift through the many hundreds of tickets that we get globally around the world. And it highlights where there might be a particular threat that we can then go back to our customers and suggest countermeasures that they might put in place to try and overcome cyber issues. The middle application is actually from our aircraft engine business, where on the turbine blades, they're made of a single crystal nickel alloy. And these are individually inspected. So what we do now is we have a robot that effectively spins the blade around, and we take photographs from many different angles. And then the AI automatically then analyzes the surface for any defects. And we can analyze a single blade in about 5 minutes with a huge degree of accuracy. And any anomalies we can then highlight, and we can see whether that blade has passed its quality inspection. The one on the right-hand side is where we work with a ferry customer, and we looked at a year's worth of their operations on one particular ferry. And we looked at the tide, we looked at the speed of the vessel, we looked at wind and weather conditions. But what we did is we looked at how they operated the vessel, and we suggested changes that they could make in their timetable and also the speed at which they operated. And that levied around about a 7 to 8% decrease in fuel consumption and emissions as well. We go to my second slide, a couple more examples which are more relevant to maritime. We have our own sort of algorithm, which is using neural networks, which is looking at the engine performance. And we've used this very successfully on our engine test beds to look for anomalies and to detect them so much quicker than the human being can be, and even prevent catastrophic failure on our test beds. Because clearly, when you produce an engine, the most critical phase is after you put it together, does it actually work? Which is why we do factory acceptance tests. And it means that we're training this algorithm up on thousands of engines every year now. So it's getting very, very good at picking up what the anomalies are. And we've rolled this across all of our global test beds around the world. And we're now beginning to use this same model with customers' engines. And there's an example on the right-hand side, we're using the rail application. So these are rail power packs that sit underneath the train. And they're helping to identify not just engine issues, but also system integration issues between the train and the engine themselves. So I just thought it'd be useful to bring some examples to you, to give you some examples of how AI is being used, not only in customer operations, but also in our own operations to help us and help our customers. So thank you very much.
Thank you, Kevin. Great. Lovely that AI is coming all over the place, and therefore I will start with a tricky question. Back to the automotive world. I asked you about how you deal with data and the fact that you need to get the agreement or not of the owner to do it. How does the automotive world has actually dealt with that issue of data protection, gathering data, and then obviously feeding AI with data without necessarily asking for agreement?
Okay, let me give you a general answer. So today, let me say, today in the automotive market, I would say the big problem is not getting the data with dealing with privacy. The real big deal today is moving towards fully autonomous cars. So at that point, the problem is privacy, of course, but is much more safety and much more national security. So imagine a world where there will be thousands and thousands of robotaxi in our cities. This is the future that is going to happen. So we like it or not, it's going to happen in the next 20 years. And they will mostly replace all the cars. Okay, so this scenario is extremely positive for the environment, for the sustainability, for the safety, for the layout of the cities. Behind this scenario, there are three threats. The first is, let's say, privacy. You're right. So all these cars can collect data, and this data can be brought outside Europe, for instance, if the AI is not European. So problem number one, so the lower level problem. The second problem is safety, of course. We are talking about AI for physical system, which is the highest step of AI. You know, there is let's say, a classical AI of perception. There is the AI of agents. Okay, this is the second step. AI for physical system is the third step. So there is a big issue of safety because there are, let's say, AI which is driving something. The third level is a potential threat for national security. So imagine what these cars can do in principle if this AI can decide not to work properly, can be transformed potentially into weapons. So these are the three levels where the privacy is the lowest one. Situation now is that US and China has developed massively this technology. Europe is far behind. So EU today is facing a big problem, and we have to take a decision. So this year, this problem came out very clearly. We have to catch up and to develop our technology. It's fundamental for keeping, let's say, our automotive technology, automotive market, automotive industry, and to keep our national security.
Thank you. So privacy, in a way, doesn't really matter. It's autonomy
it's a problem, but it's the lowest level problem in this big scenario.
So when it comes to shipping, yachting, or transportation, in fact, mobility, what you said, I can clearly imagine it as we talk about water taxis being robot water taxis between Nice and Monaco. You know, this is the thing that we've been asking for decades, but never happened. How does ABS see that? I mean, the fact that if you look at automated shuttles, automated boats, and having yachts as a service, whether it will ever happen or not. From a regulation standpoint, what do you learn from the automotive, and what do you see being different or not applicable in yachting?
Okay, so when it comes to maritime versus automotive or any other transportation sector, there's a lot to learn. maritime tend to lag quite considerably. We can kind of understand pitfalls and failures of different sectors, but at some point the maritime industry needs to kind of step up and pioneer their own way. One of these big kind of discussions when it comes to autonomy is treating every discussion with a client as a completely unique conversation. What would work for one client wouldn't necessarily work for the other, and vice versa. So that's why we try and break it down rather than saying an autonomous vessel is more autonomous functionalities on board, because if you kind of break that down further, you can have an unmanned autonomous tug, you can have an unmanned, a reduced manned yacht, and a cargo carrier from West Africa. All of these would be within a certain body of water together. All of them would be having to intercommunicate to one another. So being able to kind of simplify it down as to saying you've got driverless cars on the roads, it's not quite as kind of easy. It's much more complex scenario to kind of pursue. So with that being said, we're kind of trying to take a stance where we're establishing kind of clear, safe criteria. So, how do we kind of make operations on board more autonomous and just reduce manpower rather than kind of, let's eliminate crew all over. It's more of a case of how do we kind of reduce the cognitive workload for the officer or the crewman, and how do we just kind of make their day-to-day operations a little bit safer.
What you said, what's interesting is obviously, in a way, it's more practical or easier to become AI-driven on board boats when it comes to routing or improving efficiency. But then you mentioned safety. And obviously, when your Tesla stops functioning or your autonomous car stops functioning, it's pretty easy to escape the car, right? Whatever happens with it, whether it's turned into a weapon or not. On a boat, you can't. Obviously, the safety matter. And therefore, what do you foresee, or from, again, regulation standpoint, of being able to ensure the safety of the crew and passengers on board in a more and more autonomous or AI-driven boat?
Well, I think kind of when you talk about safety, we kind of have to kind of break that down a little bit further into is it operational safety, is it cognitive safety? Because one key discussion that always gets brought up is if you've got a system that's continually working to think how to kind of make fuel savings, route adjustments, the way that the IMO are writing the current iteration of the mass code, it very much features the human has the overriding decision. Now, if you kind of have an officer on board who's just doing their daily work and you're continually alerting them, then at what point are you kind of adding to that cognitive workload rather than relieving it? So while it's important about safety, it's kind of about safety management as well. There's a lot of different kind of subtopics that we can go into about AI. Like I said, when it came to the challenges, I showed that quick snapshot of this is what we can kind of establish as 5 potential. But when you break that further and further down, once you get further into the core of it, it's not just a simple one size fits all kind of attitude.
Thank you, especially when we think that the amount of incidents or situations arising on safety matters is actually linked to a lack of what we could call a safety culture, especially when it comes to the crew.
Yeah, absolutely. And I'd also like to kind of factor in the, playing devil's advocate, we are holding AI to a much higher standard than what we're holding on board personnel. We expect officers to be able to make the best judgment, the best kind of choose the best outcome for the vessel. Yet we're considering that autonomy AI needs to work 100% of the time. So we're holding two different operational functionalities to completely different standards as well. So there's that to factor into the decision too.
Thank you. Kevin, I could see you nod. By the way, you're on the very, very big screen within the room.
I can
so everyone can see. You can see that
myself. Yeah. So no, some great points that have just been made there. what we're doing is really supporting operator assistance and certainly around the maintenance of engines, and also making access to critical information quicker and accurately. So, for instance, ingesting into large language models all of our, documentation, service notes, and making that such that you can query with very simple questions. So what you're trying to do is as Yevon was saying, was reduce that cognitive load. But what we never want to do is we never want to take the human out of the loop, and always allow the human to have the final authority on any decision making that's made. Just supporting that last point, I reached down to get this book. It's by John Adams. Sorry, you probably can't see it, but it's called Risk. It was written in the 1980s, and it just talks about the human's propensity to take risk. And it talks a lot about cars and sort of seatbelts and, things that we take for granted now. But the key thing there is that we do take different risks when different things are in control. And I think when you know that some autonomous system is in control, we do have, as human beings, a real fear that something might go wrong, and we therefore want it to be that much more reliable than we will tolerate from ordinary humans. If you think of driving, driving in some parts of the world is terrible, and people get killed all the time. But we want AI to be zero tolerant to accidents as they happen. So we do need to have this debate about, what standard do we actually hold the AI to? We can't make it 100% perfect, but it can be a lot better than when humans are actually in control as well.
Thank you. Sorry. One of the things that we didn't touch upon, talking about AI, is on the, I would say, the manufacturing side. How AI innovation innovations can be driven by AI when it comes to the manufacturing processes, improving, developing. We were talking about propellers earlier. How now computation can help design thousands and thousands of different types of geometries. When it comes to the shipyard, is that something that, and obviously we can compare with automotive, AI innovation or AI-driven innovation can also come into play? Same thing for the engine manufacturers, after all, to improve the technologies. And is that something that you're already using or implementing in order to develop your new products, or not yet?
Okay, for the, let's say, improvement and operational efficiency of the processes, AI is for sure something that can help with automatization. When we talk about serial products, clearly there is a production line and the robotization is already there. Artificial intelligence can make a step towards, let's say, sustainability and carbon footprint, efficiency, whatever. When we go to custom projects, like, for example, the ones that we are building, the super yacht yard, clearly there is another step in the middle to do, so robotization and then artificial intelligence. So if we look at the technological level of the shipping industry, we are a bit in the middle. So Fincantieri is one of the leaders, for example, in that sector, and they are launching in 2026 an intelligent vessel that will have on board already artificial intelligence, can help human beings to take the right decision. They are using autonomous welding systems. I have to say we are a step behind in these terms. We are 2 steps behind if we look at the automotive industry. But we know that artificial intelligence has a value that we need to catch somehow. So I would say in the future, medium to long term, it will arrive everywhere. It is more a discussion about how do we handle the ethic, so the first, second, and the third level of problems that the professor were mentioning, and always keeping in mind that the human being is at the center. It's just an help. Artificial intelligence is just an help beside the human being, but the final decision is on us.
And what about standardization then? Because ultimately, if you put AI in charge of developing the products and everything is optimized, whether in automotive and.
But I mean, again, if we just during the panel before, Lateral was talking about CFD. If you want to optimize the iteration of CFDs, and artificial intelligence for sure can give you a hand. When we talk about creativity, that is the additional struggle you need to make to make innovation. Generative artificial intelligence can help you, but again, is something that is just can give you another confrontation, a challenge. The final idea and has to come by the human being.
Thank you, Kevin. I see you nod. You want to add something before we get to the panels and the audience's questions?
Thank you. Yeah, I'd like to support that point. I mean, we are using AI I showed you some examples in quality control and testing. It's also used to gather knowledge and capture knowledge, as it were. But our engineers are always in charge of the design. It's not going to give us creativity. It could really help us in terms of exploring the design envelope. But in highly regulated industries like aerospace, marine, and rail, you have to be able to go back and justify how you got to that particular design feature or critical shape, as it were. But the real liberation comes when you've got AI and additive manufacture, and you add the two together, where you can create geometries which you just cannot create with normal manufacturing processes. So those two technologies together do open up that whole design envelope, and I can see that in lots of different industries coming forward.
Thank you. Thank you very much, gentlemen. A few questions, couple of questions from the audience. I don't know if it's the right, yes.
Yes, thank you. Got a question for Kevin. My name is Giel Loef, I'm from FatShip, custom superyacht builder. Spending a lot of time in data collection for years and years and years. One of the things that I feel is our issue is that we have actually quite a low value chain concerning the data. I see the data as the new gold also for us, but if you compare it to aviation, for instance, you've got a couple of series, a couple of certified engines with thousands of units being sold with the clear value chain, because the airline, the aircraft manufacturer will be, well, screwed if something happens. In the maritime atmosphere, also in yachting, we have thousands of series and only a couple of units sold. Ferretti sells quite a few. We typically sell one of a series, so custom. Yeah. And we always have to combine a data landscape with all these different subcontractors that come on with their solutions, and they're locked in with their hardware. Now there is a lot of money. You have 30 different suppliers with their own data collection unit. That's not very safe if you connect it to the internet. So what's the solution to our problem, Kevin?
That's a great question. Yeah, aerospace is quite lucky. You know, there's only a few engine manufacturers, and we collect gigabytes of data every single flight. In what we're doing in the engine space is we actually pull together data from lots of different applications on our engines, because although the engines are used in single series of yachts or ferries or tugs or even naval vessels, that, you know, the way that they're operated and the data that you get back in terms of the degradation and the faults and the failures is very, very similar. So you can pull it together and you can get several thousand data sets together if you're allowed to have the information shared. And I think earlier we talked about data going across borders and people not really being reluctant to give up that data, because data is seen to be, you know, a commodity which you can then leverage value out of. I don't think there is a simple solution to this, although the EU Data Act that's coming up now is now really, you know, sort of trying to open up that data environment to make sure that it's not a closed shop. So manufacturers don't have just access to the data. They have to give that data up to their customers or their customers' third parties. So I think that sort of initiative from the EU will help, certainly in the EU territories. The rest of the world will have to see how that follows on.
Thank you. Thank you, Kevin. Thank you, gentlemen. Kevin, stay online for the photo. And please give them a round of applause. That should be an interesting photo. Thank you, gentlemen. Thank you, Kevin. Sorry you couldn't be with us. Yes, indeed, the French strike, well, it's not quite usual on, obviously, before the summer holidays. When it's not the trains, it's actually the planes. So at least it's not the boats. For our last session this morning, which is going to be about cybersecurity, you can see how this all wraps it up nicely. I'm calling Luca Cara on stage, who is the Marine Automation and Cyber Security Product Manager at Arena Marine Consulting. Carlo Zasfic, who's R&D Manager at the University of Rijeka. Henry Clack, who's a partner at HFW. And Andrzej Gab, who's the Director of Maritime Cyber Security Hub for Ernst & Young. Thank you. Sorry, it's been a pretty dense, intense, hopefully fruitful series of panels and keynotes. Everyone is probably a bit tired and hungry, but I'm sure they're going to entertain us very interestingly on cybersecurity, which is obviously becoming one of the key topics nowadays, along with AI. So let's start with Andrzej. Okay, I don't know what's the order of the slides, so it's going to be a surprise. Let's try.
It's mine.
It's yours. Okay, great. So you're the ones. It should be working. Tap, tap. On. Yeah, on.
Tuck, tuck. Yeah.
It's on.
Thank you very much. My name is Andrzej Gab. Andrzej is Andy, so it's better for you to understand that it's Andrew. I'm a leader for a Maritime Cybersecurity Hub in UI, and I am member of Maritime Cyber Guild. I will mention about it later. So as for me, as you see, the cybersecurity now in the conference is the last point. So it's not so jazzy like, noise pollution, like decarbonization and so on. But believe me, it will start to be a main point, because as I'm listening all the day, and I'm a cyber guy, I'm an engineer. So if you say noise pollution will be gathering some data, I'm counting the CPUs, I'm counting the processors. So, that's like several processors to gather data, several to process it, several to storage it, and several to give out to the public. Yeah. So now Yacht has got plenty of CPUs. Every boat, every aviation rig, and every oil rig, and so on. So as for me, in cyber, we'll be starting to have challenges. Let's say challenges, not problems, challenges. Can we switch to the next slide? And I tried to find some challenges we have in yachting. It is very similar to shipping, but not the same, because yachting is very close to the amateur use, to the home use. It is a little lower. But as I see, and I have some experience in touristic cruises, which is barely say hotel on the waves, and there are plenty of people using their phones, using their Netflix access, using all the things they would like to have home on the ship. So first thing is ransomware. And ransomware we should be aware of, and we should be afraid of. But ransomware is very, very easy attack. And it is very not sophisticated. What we see will be challenged in the future with more sophisticated attacks. And if we can get into navigation systems, if we can get into ACTIS, if we have bad architecture for that, we'll have problems, because attackers, hackers could get into even without our notice. Yeah. Just a little back. And what we see, we are fully connected. As we could say that 20 years ago, ship setting out was a separate island. Now it is very connected. It is not only gets data from the world to the ship, but it is connected that some ships can be reached remotely. So remember that. You are connected, even if you are at the open sea. That's from my side, beginning. Thank you.
Thank you. Thank you, Andre. I don't know who's next, so let's see.
It's me.
Where are you? Ah, okay.
Yeah.
Luca.
Hello, everyone. My name is Luca Carrà. I'm working from RINA, that is a classification of societies. I'm jumping now also for the consultancy side. I've just included here some provocative images and sentences because we need to make a reflection and we need to make a thought about what we have now that is floating in the middle of the sea. And today, when we talk about yachting and luxury, we have something just close to us that is not anymore a boat, but is something that is really complex. It's an ecosystem. It's a system of systems, mainly computer-based, mainly composed by an hardware and software, interconnected. So there is something that we need to understand deeply, that what was done traditionally to consider the luxury like just a shape, today is something that have to consider the really heart of these kind of jewelries that are sailing the seas. And for sure, there is true. We thought about communication. There is data, a huge amount of data that have to be collected. So transparency, what means? If there is the trust in the data, so that is transparent. But to let it trust, you need security. At the end, as the colleague said before, this is the really core. At the end, the new design of the yacht have to consider the cybersecurity in their DNA from the really beginning of the concept of the design, not an add-on, could not be anymore an add-on. Luxury also highlight privacy, also highlight a lifestyle, an experience. But what means? If we have all this world interconnected, we need to understand that we are open. The surface attack from malicious or who want to do something that is not so good and nice, it's wider than before. But you need also to understand that what we have on board now on this vessel, you could go on the next slide, is something that from a class perspective is a blurry area between OT and IT, something that is really concentrating in the operational aspect of the boat, of the vessels, together with IT, that is something they take data and send somewhere else. But moreover, there are, in terms of interconnection, this kind of, we have together automation, domotics, we have entertainment, we have business that are running on the same backbone of the network of this jewelry. So at the end, again, the hacking is really very challenges. Another thing that is for our perspective, something that have to be highlighted. Cybersecurity is not for malicious. Cybersecurity also including some software update that is not going in the right direction, some data corruption. And so we need to understand what need, again, transparency, in what we need to trust. And the rules with the new requirement E26 and 27 are just putting the basis. And I would like, again, to highlight the basis. A lot of times someone came to me, oh, please, just tell me what is needed. I don't want to do something else. But we are talking about luxury. In luxury, it means cutting-edge technologies, new solution, something that is a novelty, some to be a step forward, the requirements. So that's the why we need to open our mind to create a new mindset, a new approach from the really beginning of the design, considering in the DNA of the yacht that the cybersecurity is really the core.
Thank you. Thank you. And who's next?
That's me. Yeah. So hi everybody. My name is Carlo, coming from Croatia. As mentioned in the presentation, I'm at the Faculty of Engineering in Rijeka, also leading my startup Hartera Robotics that we are using and developing a new way of the method of securing those data, but not on the software level, more on the hardware level, because these gentlemen also mentioned how data is important, how those luxuries going higher and higher, and you can go please on the next slide. So brief overview, not going too deep. We are using different FPGAs hardware to make a quantum hashing, so we can have a good key of our houses with data and to secure, between two clients, peer-to-peer, and those communications are, hashing and securing by quantum levels. Why is that? Basically, everybody is using computer, iPhones and so on. It's based on only two stages. It's 0, it's 1. But in the quantum, it's between those two different stages. It's much more to using those kind of signals to hash those codes, and it's very making it difficult to decode it, because showing on the quantum computers every day are more and more in our areas that can easily unlock your passwords. For example, may I suggest that many of you, maybe have a password that hits, I don't know, 10 letters with specific characters and so on, and making much more longer, it doesn't really meant to be secure anymore, because the quantum is you're gonna unlock for like a seconds, and that's why we have starting to do this in different method, not on the traditional way of the software, securing some. So yeah, thank you.
Thank you. Interesting. We'll talk about solutions. Indeed.
So over to me. My name is Henry Clack. I'm a senior associate with HFW. For those of you who don't know us, we are one of the largest shipping law firms in the world, with over 150 shipping lawyers in offices in most of the major maritime hubs. Next slide, please. So why are yachts a target? As we've been talking about a lot today, yachts are increasingly becoming connected to the shore, and with that comes vulnerability. In particular, the need for guests coming onto the yachts and being able to immediately connect and continue to run their businesses and their personal lives, again, is a particular issue. And given the nature of the individuals using these vessels, the data which they bring with them is particularly sensitive. I have been involved in cases this year where there was a cyber incident, and part of the files that were taken related to the family trusts, the funding structures behind the yacht ownership, and all of this highly, highly sensitive data. And finally, the other problem I just want to talk about is the crew. The crew are some of the most important people within this ecosystem. You can have automated processes, systems, but if the systems you put in place slow down or block the crew's day-to-day activities, the crew will find workarounds. So at the heart of this problem is training for the crew, so that they understand the importance of what they are doing and the need to protect the systems on board the vessel. Next slide, please. But I'm not here just to talk about problems, it's also worth talking about solutions. Having a clear incident response plan in place, running regular drills, including penetration testing on the vessels to understand where the vulnerabilities are and trying to protect them as far as possible. having the right form of insurance, the normal hull and machinery policies which are in place on these yachts will exclude cyber. So there are bespoke policies on the market which allow you to get that coverage. And finally, if, unfortunately, you were to fall victim to a ransomware attack, before and you take the decision to pay that ransom, you have to be sure that that payment is legal. I'm not sure of the legal situation here in France, but I know that down the coast in Italy, just across the border, arising out of the mafia kidnappings of the 1980s, the payment of ransom is a crime. So in these situations, you have to be aware of the legal structures that you are in before making any such payment.
Thank you. It's pretty scary, all that you've said, all the four of you, especially towards the end of the morning when we were trying to be optimistic about things. So I actually have a very simple question to start with. To what extent do you think that yachts nowadays are cyber-proof, or at least have? I'm not even talking about the crew and cyber safety culture yet. We'll talk about that afterwards, but that where systems are actually properly at least protected to avoid being hacked into.
Well,
if you say none, I could understand.
No. Nothing is unhackable. Even all the most complicated infrastructure, there is a weaker point, always. But this is not the point. We need to focus that we need to adapt a new world, resilience. It means to be prepared to be there in the right moment. Jumping back to the solution, we as a classification societies, we need a technology agnostic just to stay a little bit outside to understand if it is applicable or not, if it fits the regulatory framework or not. But at the end, we need to evaluate and understand if that solution for that particular yacht, for example, fits for exactly what it needs. And here is the point. There is no appeal for anyone. There is always the solution that fits that particular infrastructure that is identified by the design. It means that we need to work with the designer, with the makers, understand how they protect their system first, how the integration of the system are protected, and it doesn't mean also to have a firewall, something more deep inside. We cannot work on OT device as IT system. They have very different needs. They need to operate continuously. So we cannot stop just, oh, hey, password, new requirement, and then stop the operational. Or, hey, I have to make a software update, stop again the operational. Cannot work like that. So also the makers need to come close to understanding really the needs of the operators, but we need to provide also tools to operators to understand what is happening on board, to be there in the right moment. They cannot discover after. GPS jamming. They cannot discover to be somewhere else when it's too late. And so we need again to work together with the four-end approach or six-end, including the designer, shipyard, owners, just to find the right solution. It seems complicated, but it's just a terms of methodology to be adapted. It's something that have to be knitted in our mind that to be future ready, we need to work in a different way. We cannot stay anchored in what we have done till yesterday or make a copy-paste with a patch. It's not anymore like that.
Okay, thank you. Some other comments? Because otherwise I have a question for the shipyards based on everything that they said about anticipating and having that, cybersecurity matters in the DNA of the yacht before they build it. Is that something that any of the shipyard community here would like to? Where do you think you stand at the moment, Fetchip? I'll give you a mic.
So it will be more interactive, I think.
I sit down for this, okay?
It's a long one then.
No, I think this is a very important topic. I was just talking to Engel of Lloyd's here. Ajax has guidance on cybersecurity, right? They will only be applied on passenger yachts, so that's a extremely small part of the yachting fleet. So there's no, say guidance. So it's all voluntary. If we go through the process, we do that every now and then voluntarily. You will find out very interesting stuff. And it's all about the systems and also the operational level. That's how these guidelines are made. So it's not only for us, for the systems, for our co-makers, but also for the crew. So it makes a huge amount of sense. Dare I say this? Yes. But it's also costly. So we need to also look at so what is truly required. It's not for every yacht, not for every system. It should be more system-based. I think the certification of the system. Crew cannot be crew certification. Because otherwise you create you always will run in a circle, and you need a lot of people to run in that same circle who might not be so capable to run in that circle. So I'm not really sure whether you get somewhere.
Yeah.
So we need to rationalize the process.
Thank you.
And perhaps one thing I also added here is that we have spotted that suppliers, co-makers, are just adding connections. Because they need the data.
Yeah.
The data is in your goals, right? So there's not one connection, not one 4G, 5G. How can you detect where it is?
Okay, I could reply.
Yep.
Okay, so you have touched a lot of things that are the real world, instead what is written on the paper. Rules at the moment came out from the 1st July 2024, mandatory for a specific kind of vessels. Yacht is something that is above 500 GT and 12 person. But I would like to highlight something that is important. We are talking about technology and how it is integrated. Sometimes this is not anymore linked to the size, but in how the solutions are adapted on board. Then we need to go into interpret the rules, because as maybe are written, there are some boundaries that are really strong to be, and there is a challenges to be fitted, okay? That's why we need, from the very beginning, to work with you, because we could, in the next revision of the rules, introduce some aspects that are much more close to the operational than less theoretical. And this is something that is an evolution, okay? Cost. We have seen here on this floor also bank. They say that blueprint or the investment in the sea, so in the yacht, is something that have to bring value. And cybersecurity is a value of the future, because at the end, we are not anymore talking about traditional technology, but we need to understand that it's something more, that it's much more pertaining to software. ABB told explicitly, their systems are software dependent. So if you don't trust in that, and you don't invest, then you have to face cost. Cost is something that is faced when something happens. And you don't know where you go, because something happened bad, not so bad, light, or very badly. So you have to rebuild something to the very beginning. That's why, again, we need to work together to find a way to achieve the adequate level of cybersecurity and to be resilient.
Yes, please, Andrew.
If I can add some things. One thing very important to mention. Cybersecurity is not only about hackers. There are two modes: intentional damage and unintentional damage. So I think this second one will be raising much more than the first one, because our systems are more complicated. There are vulnerabilities. We see if you've got CPU, processor, you've got software, you've got not often badly written, but it is it has some vulnerabilities inside, and they can be exploited unintentionally. So that's why cybersecurity is important, and it is a value, how it was mentioned. So please remember about that. And one thing, I don't know how do we treat it, because there is IT, OT, but I would like to express this for maritime. There should be pointed that there is an MT. The difference is that for OT things, we've got guys who know how to operate. There are mechanics, there are electric officers and so on, and they know their job. For MT, if your GPS is broken, ACTIS is broken, you don't have clue how to fix it on the ship. So there is, and it is different than IT. So I would like to express this. We should point that there is MT. Thank you.
There's no cybersecurity officers on board.
Unfortunately, it's normally a role which is given to a crew member who is already flat out involved in his other roles on board the vessel, and he might not necessarily have the right training required. So what I would like to see is an ETO expanded role and given the time to perform that role properly. Now, in the commercial realities of yachting, that's not always easy.
So ultimately, it's one of the first issues in a way is lack of training and lack of competence on board to be able to handle it.
Jumping back to what the colleague said, now if you bring your car to your mechanics, you don't find anymore the mechanics. You find almost a guy that is just playing with software. So again, the operational aspect is moving in that direction. More and more people on board have to be trained and aligned with tools to understand what is happening on their environment. And so transparency, it means to have a clear list of what you have on board and what these are protected, how they are integrated and how are protected. Jumping back to the coast, we have to make an observation. Yes, cybersecurity is something that is going to don't be seen. It's hidden. You don't smell it, you don't touch it, you don't feel it. But when you feel it, it hurts. That's the point. And it's something that now we cannot consider anymore apart. It's something that cannot fall anymore as an additional layer or something that, the owner will take care about that. In this URI 26 is clearly indicated who is the responsible of what. Shipyard from the very beginning and the designer are responsible to create an adequate set of documents to be given to the owner that became the responsible to maintain the resilience. This is the very key point where we have to think about in how to evolve the way to build this jewelry of the sea.
Carlo, as a developer of solutions, based on what we said, do you see a way forward that would mean that you actually can do without the cybersecurity officer on board, or is that something that, I mean, whether it's AI-driven or is something that can be avoided or limited thanks to your solutions, or how do you see the near future taking place? Because obviously everyone is pretty much behind track on cybersecurity on board anyway, so how to go forward?
Well, everything is great until the problem shows up. So, yeah, we're talking about if it's important or not, but for example, in Hartera we had we developed a robot that polishes boats' hulls in dry marinas. And yeah, cybersecurity not so big thing, like not so important. But imagine if some kid thousands of kilometers behind you just started to control your products, robots, whatsoever. The second thing, yeah, it's a marathon, it's not a sprint, definitely. You have to educate it, you have to show, but that's the part when you 20, 30 years, you didn't know how to use a phone, for example, on the touch, and so on, and now everybody has it. Maybe it's more important than an ID today. Just to make a sample, if somebody lost his mobile phone, how it reacts on that. So yeah, I also agree with the standards. You know, every protocol, every product has its own protocols of communication standards that you have to really read the documentations and so on. But just from my perspective, we are a lot of listening is included with people that you really want to apply those new methods. And yeah, that's maybe the best way to do it. When we started with this decentralized with the quantum, you know, algorithms and so on, we just listened with the people that really are interested how to secure their, you know, data product, and we really want to tailor it, you know, to be as much as easy to apply. Yeah, it's a marathon, I would say. For the question about the AI, at the end of the day, I just want to look as a tool. So not something that, you know, gonna take, for example, I mentioned this polishing robot. In the start, nobody wanted. When oh, you're gonna take our job, you know, take our data. Data is everywhere, and it's a problem not solving, not to have that problem. So problems, okay, they were gonna occur eventually, normal, but how to deal with that situation is more important. And for those kind of products, they were talking about, you wanted to take our, you know, polishing jobs and so on, but when you mentioned you use like a drill, like a tool, then the just table turns around. So that's the way. A lot of listening with the customers, a lot of, you know, interviewing helps our engineer, you know, how to tailor and make those, especially in the hardware sector. So it's not like on the software, you can cancel the programming that you're running, but on the hardware, you really want to make sure what are you doing. So yeah.
Thank you. One last question from me, and maybe one or two from the panel before we close off. We talked about crew, we talked about culture, and obviously having the right people on board to understand it. One of the things that happens with yachts and with boats, generally speaking, is that you do get passengers. And as you said, passengers are coming in, and they want to be connected. So they've got devices like our smartphones that connect to the systems, right? Which are not necessarily separated from the operational systems of the boat. How do you deal with whether it's unintentional or intentional threat that can come from somebody actually coming on board rather than not trying to hack into the system as a passenger, but my own phone being used as a malware to get into the system, for example. How does that, practically speaking, is that a serious issue, or where we need to protect everything from outside people, or it's easy to deal with?
I think a completely segregated guest network is an absolute must.
Yeah.
They cannot be allowed to come into contact with the operational networks on board the vessel.
This could become part of the new experience of the guests. They need to have their own network interconnected with the right things. And everyone have to be cautious about that.
As in my experience, because I visited several cruise liners, and there is a separate, of course, network connecting to 6, for example, Starlink communication rigs. But of course, still, there are some connections from the operational network to the guest network because there is some information they need, for example, to reserve something, to make something happen, so on. In details, I can explain offline. So the information travels from one network to the other, but it should be highly, very detailed, monitored. And if I can, from the last word, I would gladly see next year that cybersecurity will be a part of requirements for the boats, because if you implemented AI this year, I'm afraid of badly designed AI. As a cybersecurity guy, I would like to see AI cybersecurity also. And not only in boats, but also ships, yachts, and everywhere. Yeah, so that's what I would like to see, and if I can have some ask for you. Yeah, that's all, because we can talk to the end of the day about cybersecurity and with the auditorium.
Thank you. Good point. Maybe I have a challenge for all of you. Is you take control of one of the small boats out there, you know, remotely, and see how you can actually. That could be an interesting challenge to do.
But it's not so difficult.
Not the big ones, by the way, the ones from the students.
Okay, yeah, but also the other one.
No,
much more easy.
No, we don't want to be responsible for touching the big ones, but you can try and play with the small ones. It would be an interesting challenge and a good lesson also for the students from the universities, obviously.
Sure. Think about hacking village. So they are trying to race, and there are some hackers trying to get the remote control.
Yeah.
Well, until next year, when you do that, please, all of you, first, thank you, gentlemen. Thank you. For very interesting, a bit pessimistic, but still very interesting topic and discussion.
It's optimistic. I'm a Subway guy, so I see that I will work until the end of my life for that.
Exciting.
And it's exciting.
And since we're talking about the Energy Boat Challenge, I really invite you to go down to the quays, have a look, talk with the students. I mean, they're obviously very focused on doing their stuff and improving solutions for decarbonization of the industry. But it's really fascinating, and the amount of passion and involvement from all the teams from all around the world is really worth having a look. On this note, we'll just close off this session. We're a bit behind track. Well, less than half an hour, so it's not too bad. We started 10 minutes late. Time for lunch. You're free to go. It's behind you. And enjoy your afternoon. Hope it was interesting, fruitful, pleasant, entertaining. And thank you again, gentlemen. Please, if you can stand in for the last picture of the morning.
Just if you could stay seated for one more minute, I promise it's going to be only one more minute. So once again, thank you very much for joining us today, despite the fact that there were a little problems with the airport traffics. So thank you very much still making it here today. And we would like to invite you to join a networking lunch with us. And I also would like to highlight the fact that the eDock, the YCM eDock, is open for visitors. So if you are interested in CE-certified hydrogen boats or fully electric boats, please visit the eDock with your badge, with your speaker badge. You can also ask for a sea trial, and on availability, all the present people can hop on a boat with discussion after discussion with the company. So please take this chance and also visit the students downstairs and the eDock of the YCM Marina. Once again, thank you very much and bon appétit.